Rising from the golden sands of Egypt, the Great Pyramids have stood for over 4,500 years, silent, stoic, and steeped in mystery. How could a civilization without iron tools, cranes, or computers construct monuments so precise that modern laser measurements struggle to find flaws? Even more astonishing, these ancient architects seem to use mathematical concepts that wouldn't be officially discovered until thousands of years later. Did the ancient Egyptians stumble upon secrets of the universe long before we gave them names? Or is there something we're still missing, hidden in the stones and stars? Before we begin this ancient journey, let us know where in the world you're watching from and what time it is for you right now. Post it in the comments below and settle in for a fascinating ride into the past. A very long time ago, more than 4,000 years in the past, the ancient Egyptians developed a truly impressive and surprisingly advanced understanding of mathematics. So advanced, in fact, that it was far ahead of many other civilizations of their time. But what's really fascinating is that they didn't study math just for fun or theory. They used it every day in real life, whether they were farming the land, building gigantic monuments, or keeping track of trade and taxes. Their number system was based on tens, just like ours today. They had special symbols for numbers like 1, 10, 100, 1,000, and even larger values. With these symbols, they could write down and work with very large numbers easily, something that was extremely helpful when organizing huge building projects like the pyramids. Geometry, the math of shapes and space, was one of their strongest areas. The Egyptians could carefully measure and calculate the areas of rectangles, triangles, and even circles. They could also figure out the volume of shapes like cylinders. This kind of knowledge came in handy after the Nile River flooded every year, because the floodwaters would wash away property lines, and the Egyptians needed to remeasure their land. It was also essential when they designed and constructed their massive stone buildings, like temples and pyramids. Although they didn't study algebra the way we do now, the Egyptians had a practical grasp of it. They could solve basic equations and work with fractions, which they wrote as a combination of unit fractions that always had one as the top number. Their surviving mathematical documents, like the famous Rind papyrus, show they knew how to solve complex problems involving the sharing of goods and the planning of a large-scale building work. The ancient Egyptians were not just brilliant builders, they were also masterful mathematicians. One of the most stunning examples of this is how they seem to have used the golden ratio in their pyramid designs. The golden ratio is a special number, about 1.618 to 1, that appears often in nature and in beautiful works of art and architecture. Although the Egyptians probably didn't write down the golden ratio the way we do today, they seem to understand its beauty and usefulness. They built the Great Pyramid of Giza with proportions that match this ratio very closely. If you look at the slanted side of the Great Pyramid compared to half of its base, you'll find it's very close to this golden number. This suggests that the Egyptians had an intuitive sense of what was both pleasing to the eye and structurally sound. The angle they used, about 52 degrees, is not just beautiful to look at, but also very strong. This helped their pyramids stay standing tall for thousands of years. The more scholars study the pyramids, the more amazed they are. The golden ratio adds a layer of mystery and wonder to what the Egyptians knew about geometry and design. How did they figure it out? How much did they really know? These are questions that continue to fascinate scientists, architects, and math lovers to this day. But that's not the only mystery hidden in the stones of Giza. The Great Pyramids were built with astonishing precision, so precise that some experts believe they were also connected to the stars. These pyramids, which were built more than 4,500 years ago, are aligned almost perfectly with the four cardinal directions: north, south, east, and west. The sides of the Great Pyramid of Khufu are so precisely aligned with true north that they are off by only a tiny amount, less than a single degree. This is mind-blowing when you consider they had no GPS, no compasses, and no modern surveying equipment. There's also a narrow passage deep inside the Great Pyramid that points directly toward the North Star of that era, a star called Thuban in the constellation Draco. Some experts believe this might mean the pyramid wasn't just a tomb, It could have also served as an observatory to study the stars. Even more intriguing is how the three pyramids at Giza are arranged. Some researchers think their layout mirrors the three stars in Orion's belt. While this idea is still debated among historians, it shows how much interest and mystery still surrounds these ancient structures. Modern measurements have shown just how precise the pyramid alignment really is. The east-west side of the Great Pyramid is off from true north by only 3 arc minutes. That's about 1/20th of a degree. To understand how tiny that is, imagine drawing a line from the base of the pyramid all the way to the North Pole. That line would only be off by about the width of a single human hair after travelling a full mile. That level of precision is absolutely jaw-dropping. Many experts have tried to figure out how the Egyptians achieved this. Some suggest they used the stars, watching them rise and fall to find true north. Others think they used the shadows of the sun or special tools we no longer know about. Some even wonder if they had an understanding of the Earth's rotation long before it was widely known. Whatever their method, the builders of the pyramids clearly had an incredible eye for detail, a deep knowledge of the sky, and the skills to put it all into action. And the tools they used, surprisingly simple, yet incredibly effective. For example, they use something called a plumb bob, a weight on a string that helps builders find a perfectly vertical line. This simple tool helped make sure the edges of the pyramid were straight and precise. To make the foundation level and flat, the Egyptians dug shallow channels around the base of the pyramid and filled them with water. By checking how the water sat in the channels, they could find out if the ground was even, which was super important for building a stable and symmetrical structure. They also had a standard unit of measurement called the cubit, based on the length of a forearm from elbow to fingertips. This kept measurements consistent across the entire construction site, so whether a stone block was cut in one place or another, it would still fit perfectly when placed into the pyramid. Thousands of years ago, the ancient Egyptians showed an extraordinary ability to work with shapes, angles, and measurements. When building their mighty pyramids, they didn't just stack stones randomly. They used clever tools and smart math to get everything just right. One of the most impressive things they achieved was creating perfectly square corners, right angles that are exactly 90 degrees, and they did it with surprising precision, long before anyone had computers or even simple calculators. To make sure their walls were perfectly vertical, the Egyptians used a simple but brilliant tool called a plumb bob. Imagine tying a heavy weight to the end of a string and letting it hang freely. Gravity would pull it straight down, creating a perfect vertical line. Builders could then use this line as a guide to make sure the walls of the pyramid rose up straight and tall, but creating a square base, getting those perfect right angles, required even more brainpower. The Egyptians had a special technique that used a rope tied with knots to form a triangle. The triangle had sides in a special ratio: 3 units, 4 units, and 5 units. When a triangle has sides in this exact proportion, the corner between the shorter 2 sides is always 90 degrees. This method is known today as the Pythagorean theorem, named after a Greek thinker who lived over 1,000 years later, but the Egyptians were already using it as a practical tool to lay out straight lines and right angles. Before construction even started, the builders needed to make sure the ground was perfectly level. If the base of the pyramid was crooked, the entire structure would be off. To solve this, they dug shallow trenches in a grid pattern and filled them with water. Since water always finds a flat level, they used the surface as a reference. Wherever the water touched, they knew the ground was even. This method helped them achieve a base that was flat within just a few centimeters across the entire foundation, a stunning level of accuracy for such an ancient time. Thanks to these techniques, and a great deal of experience and attention to detail, the Egyptians managed to build the Great Pyramid of Giza so precisely that modern measurements show the sides of its base are almost exactly the same length. In fact, the difference between the longest and shortest side is less than 1/10 of 1%. But the Egyptians didn't stop at measuring and levelling. They also showed a deep understanding of mathematics, including ideas that wouldn't be fully defined until thousands of years later. One of those ideas was pi, the number that helps us understand circles and spheres. Around the year 1650 before the birth of Christ, an Egyptian scribe wrote a document called the Rind Mathematical Papyrus. Inside it, there's a problem that involves finding the area of a round field. The solution involved taking 8/9 of the diameter, squaring it, and using that result as the area. This clever method gives a value for pi that's about 3.16, very close to the real number, which is roughly 3.141. This shows that even if they didn't have the exact formula, they had a very good working idea of how pi behaved. Interestingly, the Great Pyramid of Giza, built around the year 2500 before the birth of Christ, seems to reflect this same knowledge. If you take the pyramid's total perimeter and divide it by its height, the number you get is very close to 2 times pi. This could be a coincidence, or it could be that the builders intentionally included this special number in their design. These clues suggest that the Egyptians had a practical, if not fully theoretical, grasp of advanced math. They may not have written equations the way we do today, but they clearly understood how to apply mathematical principles in both design and construction. To keep their building symmetrical, meaning balanced and the same on both sides, the Egyptians used several other smart tricks. One method, again, was the plumb bob, which helped make sure everything went straight up and down. Another important step was carefully measuring and marking the ground before building began. They used ropes with knots to lay out right angles and equal distances, like a giant chalk outline for a massive stone structure. For round buildings or circular layouts, they would tie a rope to a central stake and swing it around like a giant compass. This enables them to draw perfect circles on the ground, keeping everything centered and balanced. Sometimes they even made small models or detailed drawings before beginning the real construction. These served as blueprints so workers could check their progress and make sure everything matched the plan. But their talents didn't stop with measuring. The ancient Egyptians were also amazing geologists. They knew which types of the rocks were good for building and how different materials behaved. For the pyramid's main body, they used limestone taken from nearby quarries. This limestone was soft and easy to cut when first dug out, but it hardened over time as it dried in the air, perfect for long-lasting structures. For special parts inside the pyramid, such as the walls of chambers or roof beams, they brought in granite from Aswan, a city more than 500 miles to the south. Granite is much harder than limestone, and moving those massive blocks such a great distance shows just how skilled and determined they were. Even more impressive is how tightly the stones were fitted together. Many of the blocks are joined so perfectly that not even a razor blade can slide between them. The Egyptians also used gypsum mortar between the stones. This material helped slide the blocks into place during construction, and then hardened over time, adding strength and sealing the gaps. They even paid attention to how the bedrock beneath the pyramid sloped. Instead of just building on top of uneven ground, they studied the rock and adjusted their work to create a level base. This required not just good tools, but a deep understanding of how the land itself worked. However, there's the pyramid's outer beauty. After stacking up the rough blocks that made up the core, the Egyptians covered them with a layer of smooth white limestone called casing stones. These stones were cut with incredible precision, often to within a tiny fraction of an inch. Workers used tools like copper chisels, bronze saws, wooden sledges, ramps and levers to shape and move these heavy stones into place. To polish the surface, they worked from the top downward. They ground the outer surface using sandstone blocks and other abrasives to make it flat and smooth. This was a slow and painstaking process, but it gave the pyramid a dazzling, mirror-like finish that sparkled in the sunlight. Even though most of the casing stones have been lost to time and earthquakes, a few still remain at the base of the Great Pyramid. These surviving stones fit together so perfectly that modern builders still marvel at the craftsmanship. All of this shows that the ancient Egyptians were not just great builders. They were engineers, architects, mathematicians, and geologists rolled into one. Their knowledge allowed them to create monuments so precise and strong that they have stood tall for more than 4,000 years, still inspiring wonder in everyone who sees them today. Sacred geometry is an ancient belief system that explores the idea that certain shapes and proportions hold a special spiritual or cosmic meaning. People who studied sacred geometry believed that the universe itself was built on simple but powerful mathematical patterns. These patterns were not just numbers, they were thought to be sacred, revealing hidden truths about life, nature, and the heavens. In ancient Egypt, this mysterious and beautiful way of thinking was deeply connected to the way they built their greatest monuments, especially the pyramids. The Great Pyramids, especially the famous one at Giza, were not just giant tombs made of stone. They were built with extraordinary care. Using mathematical ideas that the Egyptians believed had divine meaning. They didn't just want to build something strong, they wanted to build something that reflected the order of the universe. One of the most famous of these special numbers is known as the Golden Ratio, which is around 1.618. This ratio is found in nature, in the spiral of a seashell, the petals of a flower, and even in the proportions of the human body. The ancient Egyptians seem to have known about this ratio long before it was named, and they may have used it in the design of the Great Pyramid of Giza. Built around 4,500 years ago, during the reign of Pharaoh Khufu, the Great Pyramid displays an incredible level of geometric perfection. Its base is almost a perfect square, and the way its height relates to the length of the sides is strikingly close to the Golden Ratio. Even more fascinating is the pyramid's slope angle, about 51.84 degrees, which allows its triangular sides to form perfect geometric relationships when imagined corner to corner. These measurements weren't chosen at random. They reflect a deep understanding of both form and function. But the beauty of the pyramid doesn't end with its shape. The way it is positioned on the earth is just as astonishing. Each side of the Great Pyramid is almost perfectly aligned with the four cardinal directions: north, south, east, and west. This means the ancient builders must have had a very precise understanding of astronomy. They may have used the stars to guide their work, especially since some narrow shafts inside the pyramid point directly towards stars that were sacred in their religion. These shafts were possibly designed as pathways for the soul of the dead pharaoh, helping him rise up into the heavens. When you study the pyramid's dimensions more closely, another amazing connection appears: the presence of pi, the famous mathematical constant that represents the relationship between a circle's diameter and its circumference. If you take the total length around the base of the pyramid and divide it by twice its height, the result is incredibly close to pi, approximately 3.14. Some researchers believe this might mean that the builders knew about pi, even though it would not be officially defined until thousands of years later. Others think the similarity might have happened by chance, as a result of the tools and techniques used, like using circular measuring wheels. Whether the use of pi was planned or not, the fact that it appears in one of the most famous structures on Earth has fascinated scholars for centuries. It adds yet another layer of mystery and wonder to the pyramid. It shows how mathematics and architecture were woven together in ancient times, revealing a deep respect for the natural world and the cosmos. The Egyptians didn't only look to the skies, they also looked to the human body for inspiration. The Golden Ratio appears not just in flowers and seashells, but in us as well. For example, the length of your forearm compared to your hand is close to this same ratio. The ancient Egyptians noticed these patterns and used them in their buildings. In fact, the pyramid's slope angle of around 52 degrees is similar to the angle your hand makes when you stretch your fingers wide. This angle gave the pyramid strength and balance, just as it gives the human hand flexibility and control. And here's something even more astonishing. If you take the height of the Great Pyramid and multiply it by 1 billion, the result is extremely close to the average distance between the Earth and the Sun. This might be a coincidence, but it's the kind of coincidence that gives goosebumps and suggests the Egyptians might have understood more about the universe than we give them credit for. Of course, not all experts agree that sacred geometry was definitely used by the ancient Egyptians on purpose. Some believe these mathematical connections happened naturally through their methods of building and their focus on practical design. While the idea of hidden codes and secret messages in the pyramid's geometry makes for fascinating stories, there is little hard evidence that the Egyptians meant for their pyramids to hold secret sacred symbols. What we do know for sure is that the pyramid shape had strong symbolic meaning. It likely represented the primordial mound, the first piece of land that rose from the waters of chaos in Egyptian mythology. The sloping sides, reaching toward the sky, symbolized the rays of the sun. This shape was seen as a kind of stairway that helped the soul of the dead pharaoh rise up to the heavens and join the gods. Still, the mathematical wonders built into the Great Pyramid are impossible to ignore. Whether the golden ratio and pi were used on purpose or discovered by accident, the end result is the same: a structure of enormous beauty, deep meaning, and enduring mystery. The Great Pyramid stands as a powerful reminder of the brilliant minds and spiritual beliefs of the ancient Egyptians, a civilization that saw no separation between science, art, religion, and the cosmos. To them, numbers were not just tools, they were the language of the gods. The Great Pyramid of Giza has amazed people for thousands of years, not just because of its enormous size, but also because of its astonishing accuracy and the mysterious mathematics hidden in its design. One of the most fascinating things researchers have noticed is that the pyramid seems to reflect a deep understanding of the mathematical constant known as pi, the number we use when working with circles, which is roughly 3.14. If you take the total distance around the base of the pyramid, its perimeter, and compare it to its height, the result is surprisingly close to 2 times pi. This has led many to wonder, did the ancient Egyptians know about pi over 4,000 years ago? But pi is not the only mathematical wonder built into the pyramid. Another famous number, called the golden ratio, or phi, which is about 1.618, also appears in the pyramid's shape. If you measure the slanted side of the pyramid, called the face slant height, and compare it to half the length of the base, the result is very close to the golden ratio. This special number is found throughout nature, from the shapes of seashells to the patterns of flowers, and it is often associated with beauty and balance. Some scholars believe that these mathematical relationships were intentionally included by the pyramid's designers, showing that the Egyptians had a brilliant grasp of math and geometry. Others argue that these patterns may have appeared accidentally, simply as a result of the techniques used to build the pyramid. While the debate continues, one thing is certain: these incredible mathematical coincidences, or perhaps intentions, have captured the imagination of scientists, historians, and dreamers for generations. No matter the purpose, the presence of both pi and the golden ratio in such an ancient and massive monument is nothing short of breathtaking. It reminds us just how advanced the ancient Egyptians were, not only in construction but also in mathematical thought. The Great Pyramid is more than just a pile of stones. It is a symbol of a civilization that was incredibly skilled, thoughtful, and creative. This fascination with geometry and precise design doesn't stop with the pyramids of Egypt. Around the world, many ancient monuments, from Stonehenge in England to the temples of Angkor Wat in Cambodia, seem to follow similar geometric rules. People have noticed that many of these sacred places use exact angles, careful alignments, and meaningful proportions, often connected to astronomy and the movement of the stars. Take the Great Pyramid, for example. Its 4 sides are aligned almost perfectly with the cardinal directions: north, south, east, and west. In fact, it is aligned so precisely with true north that it would be hard to do better today without modern tools. Similar astronomical accuracy can be found at places like Chichen Itza in Mexico. This raises a fascinating possibility. Could it be that ancient civilizations all over the world shared some knowledge of the stars and mathematics, or even exchanged ideas with one another? The golden ratio also appears again and again in ancient architecture. It is found not only in the Great Pyramid, but also in the design of the Parthenon in Greece and in some Mayan temples. This shared use of the golden ratio across so many different cultures has led some researchers to suggest that there may have been a common understanding, or perhaps even contact between ancient peoples. However, not all experts agree with this theory. Many of these connections are still being studied and remain unproven. Still, the similarities are so striking that they continue to spark interest and wonder. The ancient Egyptians, in particular, showed incredible care and precision when they built their pyramids. The Great Pyramid of Giza, constructed more than 4,500 years ago, around 2600 BCE, is a perfect example. Its base is almost a perfect square, with the length of each side measuring more than 230 meters, and the difference between the longest and shortest side being just a few centimeters. That level of precision is truly extraordinary for a structure built so long ago. Even more impressive is how accurately the pyramid is aligned with the 4 cardinal directions. Its sides deviate from true north by only a tiny fraction of a degree, a level of accuracy that would have required highly precise astronomical knowledge. The pyramid's slope, which is about 52 degrees, is also consistent on all four faces, showing that the builders followed a carefully planned design. Inside the pyramid, the same precision continues. The grand gallery and the different internal chambers have walls that meet at perfect right angles, and the passageways that lead up and down the pyramid maintain steady angles for their entire lengths. This shows that the builders had a strong understanding of geometry, and they applied it with great skill. Some modern studies have suggested that the golden ratio is also present in other parts of the pyramid's design. If true, this would mean the ancient Egyptians used advanced mathematics not just for decoration, but as part of the structure itself, further proving how deeply they understood the principles of design and proportion. But for the Egyptians, mathematics was not just practical, it was spiritual. The pyramid's shape was more than a clever engineering trick. In Egyptian mythology, the pyramid represented the primordial mound, the very first land to rise out of the chaotic waters at the beginning of time. It symbolized creation, rebirth, and the start of all life. The sloping sides of the pyramid were believed to act like stairs to the heavens, helping the soul of the pharaoh rise to join the stars and become one with the gods. The pyramid was more than a tomb. It was a spiritual machine, carefully designed to help the king's spirit travel to the afterlife. The entrance to the pyramid was usually built facing due north, pointing toward the pole star, which never sets, and was seen as a fixed point in the sky, a kind of cosmic anchor. This careful alignment connected the pyramid not only to the earth, but also to the universe. The very tip of the pyramid pointed toward the sky, acting as a link between the human world and the realm of the gods. Even the use of the golden ratio may have had spiritual meaning. This number, which appears naturally in the growth of plants, the spiral of galaxies, and the human body, was seen as a sign of divine harmony. By using this ratio, the Egyptians were not just creating beautiful structures, they were expressing their belief in a universe filled with order, balance, and sacred geometry. In every stone and every angle, the Great Pyramid reflects the incredible knowledge, deep spirituality, and artistic vision of the ancient Egyptians. Whether these mathematical wonders were planned or accidental, they continue to leave us in awe, thousands of years later. Over 4,500 years ago, the ancient Egyptians built a colossal stone monument on the Giza Plateau, the Great Pyramid. What continues to amaze people today is not just its size, but the incredible precision with which it was built, especially when it comes to its perfect angles and measurements. Even by modern standards, the level of accuracy they achieved is extraordinary. At the base of the Great Pyramid, the corners form nearly perfect right angles, very close to 90 degrees, with an average error of less than 1/20th of a degree. Imagine trying to get that exact without any modern tools, without computers, lasers, or high-tech instruments, just ropes, wooden tools, copper chisels, and the sharp minds of ancient engineers. This stunning precision becomes even more impressive when you consider the sheer scale of what they were working with. The original height of the pyramid was about 146 meters tall. That's nearly as tall as a 40-story building. Each side of the base stretched about 230 meters, and the entire structure covered an area larger than 5 football fields or over 5 hectares. To keep the angles that precise across such a massive space, without the help of modern surveying equipment, shows just how skilled and knowledgeable these builders were. That precise geometry wasn't just for show, it had a very important purpose. These perfect angles helped keep the structure strong and stable. The pyramid was designed so well that its enormous weight, made up of millions of limestone blocks, was spread out evenly. That's one of the big reasons it has stood tall for more than 4,000 years, through earthquakes, wind, erosion, and the endless march of time. The triangle shape of the pyramid, so familiar to people around the world, is not only beautiful but also mathematically impressive. Researchers have long noticed something very curious about the proportions of the Great Pyramid. When you take the length around the base and divide it by twice the height, you get a number very close to pi, the famous mathematical constant that connects the circumference of a circle to its diameter. Pi is roughly 3.14, and the Great Pyramid's measurements reflect that relationship with incredible accuracy. This has led to all kinds of theories and debates. Did the ancient Egyptians know about pi? Some scholars believe this can't be a coincidence, that the builders had a deep understanding of geometry and mathematical concepts. Others think the Egyptians arrived at these perfect proportions through trial and error, or simply by following what looked and felt right. No matter how they did it, the result is astonishing. That kind of precision is something modern construction workers often need lasers and advanced tools to achieve, but the Egyptians managed it with nothing more than simple tools, hard work, and brilliant planning. To put it into perspective, if the Great Pyramid were scaled up to the size of the Earth, the biggest bump on its base would be no taller than a small hill. That's how incredibly level they made it. This flat foundation was essential. Without it, the entire pyramid could have leaned, cracked, or even collapsed over time. Instead, the careful levelling helped it endure for over 45 centuries. The builders also used an extremely precise system of measurement. Their main unit was called the royal cubit, about 52.4 centimeters by today's standards. It was based on the length of a person's forearm from elbow to fingertip, making it both practical and consistent. To get even more exact, they used smaller units like the palm, 1/7 of a cubit, and the digit, 1/28 of a cubit. These tiny measurements helped the workers align massive stone blocks with jaw-dropping accuracy. To measure slopes and angles, they used something called a seked, which measured how far a surface moved sideways for every cubit it rose vertically. For the Great Pyramid, the slope was 5.5 palms of horizontal run for each cubit of height. This gave the pyramid its graceful, steep sides, angled at about 52 degrees. All of these careful measurements weren't just for looks. They were key to the pyramid's strength, stability, and perfect symmetry. Every block, every corner, every line had to be exactly right, and the builders pulled it off with stunning success. But the wonders don't stop there. Some researchers have discovered an astonishing link between the size of the Great Pyramid and the size of the Earth itself. If you measure the distance around the base of the pyramid, you get a number that equals exactly 1/2 of 1 minute of latitude at the equator. Multiply that number by 60, then 60 again, and you get the Earth's polar circumference. This strange connection has led to a fascinating question. Did the ancient Egyptians somehow know the size of our planet? Most mainstream scholars say no. They believe the match is just a coincidence. But even if the Egyptians didn't know the Earth's exact dimensions, the fact that the pyramid lines up so well with something so big and fundamental makes the whole story even more mysterious and amazing. One of the most astonishing facts about the Great Pyramid is how perfectly it is aligned with the directions of the Earth: north, south, east, and west. The pyramid's north-facing side is aligned with true north, with an error of less than 1/10 of 1 degree. That means that even with all our modern technology, building something with this level of directional accuracy would still be extremely difficult. And yet, the ancient Egyptians managed to do it with tools made of copper and bronze, thousands of years ago. This amazing alignment was no accident. It shows us that the ancient builders had a deep knowledge of the sky. To find true north, they probably studied the night sky for years, observing stars that never rise or set, called circumpolar stars. These stars rotate around the North Celestial Pole, and by watching them, the Egyptians could pinpoint the exact direction of north with great accuracy. But why go to all this trouble? For the Egyptians, such precision had many purposes. First, it helped them develop accurate sundials and calendars. These tools were essential for planning farming seasons, as the annual flooding of the Nile River was closely tied to the sun and stars. Secondly, aligning the pyramid with the heavens likely had spiritual meaning. The ancient Egyptians believed their pharaohs were connected to the gods and the stars, and by pointing the pyramid toward the sky, they may have been helping the ruler's soul rise to the afterlife and join the eternal cosmic order. This level of astronomical knowledge tells us something important. Ancient civilizations were much more advanced than many people assume. The Great Pyramid challenges modern beliefs about what people thousands of years ago were capable of. It shows us that they were not just building tombs, they were building cosmic markers, filled with purpose and precision. The pyramid's stone blocks also tell a story of astonishing craftsmanship. Modern engineers are still amazed by how precisely these stones were cut and placed. The main body of the pyramid is made from huge limestone blocks, each one weighing several tons. These stones were carved with great consistency, often measuring about 1 meter in height and over 2 meters in length. But even more impressive were the casing stones, the smooth white limestone blocks that once covered the entire pyramid. These were so perfectly shaped that they fit together so tightly you could not even slide a thin knife blade between them. Some of these stones were cut to within fractions of a millimeter, an accuracy that would be impressive even today. The entire pyramid structure also shows remarkable accuracy in its shape and proportions. The base of the pyramid is almost perfectly level. Across its full perimeter, about 430 meters, the difference in height is no more than 15 millimeters. And what makes this even more amazing is that the pyramid was built on rough and uneven bedrock. The Egyptians had to prepare the ground and measure every angle and height with exceptional care. So how did they do it? The Egyptians used simple but effective tools. Copper chisels and bronze saws were used to cut stone. Wooden sleds and rollers helped transport the massive blocks. They built long ramps made of mud brick to lift stones higher as the pyramid rose. To guide their work, they used clever surveying tools and techniques to keep everything straight, level and aligned. It was a combination of strength, skill, and smart planning. But the wonders of the Great Pyramid do not stop at engineering. The pyramid also reveals some deep mathematical secrets. One of the most curious facts is that the pyramid's dimensions seem to contain the number pi, the same pi we use today to describe circles. If you measure the distance around the base and compare it to the height, the ratio is very close to 2 times pi. That suggests the builders may have had a working knowledge of this mathematical constant, long before it was officially defined. Another mystery lies in the golden ratio, known as phi, which is about 1.618. This ratio appears again and again in nature, in the shapes of flowers, seashells, and even galaxies. Remarkably, it also seems to show up in the design of the pyramid. Some believe that the proportions of its sides, angles, and inner rooms reflect this special ratio. Whether this was intentional or simply a result of using practical building methods is still debated. But either way, it shows just how connected the pyramid is to both nature and mathematics. In fact, one of the most important angles in the entire pyramid is about 51.5 degrees. This was not just a random choice. This angle gives the pyramid its strong, elegant shape, and also creates a special mathematical relationship. When you take the height of the pyramid and divide it by half the base, the result is very close to pi. This perfect slope allowed the pyramid to stand tall and stable for over 4,000 years, resisting earthquakes, erosion, and time itself. There's also something magical about this angle from a visual and spiritual perspective. It makes each face of the pyramid look like a nearly perfect triangle, giving the whole structure a sense of symmetry and beauty. It also allows the pyramid to cast shadows at important moments in the year, such as solstices and equinoxes, which may have helped mark sacred days on the Egyptian calendar. Astronomically, the pyramid is full of secrets. One of the narrow internal shafts, called the descending passage, is pointed directly at the celestial North Pole. When the pyramid was built, this passage lined up almost exactly with a star called Thuban, which at that time was the North Star. This shows the builders not only knew how the sky worked, but also adjusted for the slow shifting of the Earth's axis over time, a movement known as precession. Even the east and west sides of the pyramid align with the equinoxes, the 2 days each year when daytime and nighttime are equal in length. From the Sphinx, the sun appears to set exactly between the pyramid's north and south sides during these moments. This shows that the builders were not just architects. They were also keen astronomers with a deep understanding of how the sky moves throughout the year. Altogether, the Great Pyramid of Giza is much more than a massive stone structure. It is a masterpiece of science, mathematics, and cosmic symbolism. Every detail, from the angle of its sides to its perfect alignment with the stars, shows us that the ancient Egyptians were far more advanced than many people once believed. They were builders, yes, but also astronomers, mathematicians, and philosophers. If there's one mystery that still leaves archaeologists scratching their heads to this very day, it's this one. How in the world did the ancient Egyptians build those breathtaking pyramids? Based on what we know today, The Egyptians didn't have much to work with, at least not by modern standards. Their tools were basic, and they didn't have access to high-tech construction equipment or advanced building materials. And yet, they managed to build some of the most astonishing structures the world has ever seen. We still don't have one clear, completely satisfying answer, but we do have several fascinating theories that might get us close. The most popular theory suggests the Egyptians were extremely clever and might have used a rather sneaky trick to pull off their architectural wonders. Picture this. As they were building the pyramid higher and higher, they constructed a sloping, spiralling ramp made of bricks, earth and sand that wrapped all the way around the growing structure. Each time the pyramid rose, the workers extended the ramp a bit more, like a never-ending staircase made of dirt. It's kind of like they were playing the world's first mega-sized game of Jenga, but with stone blocks that weighed several tons each. So how did they move these giant stones up those ramps? Well, according to the famous ancient Greek historian Herodotus, the Egyptians used sleds, wooden rollers, and levers. Imagine that. A massive team of workers pulling stones up a steep ramp with ropes, using teamwork and grit, basically turning pyramid construction into a kind of giant ancient tug-of-war match. Herodotus also made a bold claim. He said the Great Pyramid of Giza, the largest and most famous one of them all, took 20 years to complete. That's right, 2 whole decades. And if that wasn't impressive enough, he also claimed that 100,000 men worked on it. That sounds like nearly the whole population of ancient Egypt. But before you imagine endless rows of sweaty workers under the hot sun, some archaeologists later suggested that Herodotus may have exaggerated a little. By the end of the 20th century, evidence began to emerge that the workforce might have been smaller but more skilled and organised. Instead of 100,000 labourers, a more realistic estimate is closer to 20,000 workers, supported by teams of bakers, medics, and even religious leaders. These weren't just random peasants, they were a dedicated crew, possibly working year-round or seasonally, especially during the Nile River's flood season when farming wasn't possible. Then there's a theory that sounds like something out of a fantasy novel. Some believe that the pyramids were actually built from the top downward. According to this idea, the pyramids began as tall, isolated hills. Workers carved stones from the hills themselves and slowly shaped them into the iconic structures we know today. Sounds wild, right? But not everyone dismissed it. There are a few examples of isolated hills that resemble the shapes of pyramids. So maybe, just maybe, there's a grain of truth in it. No matter which theory you prefer, whether it's ramps, seasonal labour or hill quarry transformations, one thing is clear: the pyramids continue to inspire awe, imagination, and curiosity thousands of years later. Now, speaking of jaw-dropping mysteries from ancient Egypt, let's talk about that giant unfinished obelisk still lying in its quarry. It's enormous, and archaeologists are still trying to figure out how the Egyptians were planning to shape and move it. Some experts believe the workers used handheld stone pounders to chip away at the granite, but one researcher noticed something unusual. The trench walls around the obelisk had smooth, regular grooves that looked too perfect to be made by hand. According to this expert, those horizontal lines might have been created by some sort of machine-like tool, a device that removed material in even strokes, pausing occasionally and leaving behind telltale striations. Imagine a tool that rocked back and forth, brushing against the trench walls and clearing debris while carving the obelisk. Sounds kinda high-tech for an ancient civilization, right? This led some to wonder if the ancient Egyptians had access to advanced technologies we just don't understand today. And there's more. An early Egyptologist once discovered several core drills, cylindrical stone pieces that had been cut out of materials like limestone, alabaster, and granite. The actual drill bits are missing, but these leftover cores suggest that the Egyptians knew how to drill through even the hardest stones. That's no small feat. But the genius of the Egyptians didn't stop at stonework and architecture. Would you believe that they also invented the handheld mirror? That's right. Long before modern makeup routines, the Egyptians had small, polished metal mirrors. And they weren't plain either. These mirrors were often decorated with carvings, inscriptions, and elegant designs. They cared a lot about appearance, personal hygiene, and cleanliness. In fact, the Egyptians were among the first to invent toothbrushes and toothpaste. They knew the importance of a good smile even though their dental health wasn't perfect. Their toothpaste recipes might sound odd today, but they actually worked. One ancient recipe included rock salt, mint, dried iris petals and pepper, a combination that 21st century dentists have tried and found surprisingly effective. Another mix used ground ash, not so great for fresh breath, but it got the job done. That's probably why the Egyptians also invented breath mints, made by combining heated cinnamon and honey into sweet-smelling tablets. When it came to home decor, the Egyptians were way ahead of their time. While furniture decoration may have started in Mesopotamia, the Egyptians took it to the next level. They used colourful inks, decorative carvings, and even created different types of papyrus paper for writing and design. They also came up with the idea for area rugs, using woven papyrus plants to create soft, cosy mats for their homes. And let's not forget their love for trinkets and figurines. Egyptians had collections of small statues shaped like cats, dogs, and humans, made from everything from humble sun-dried mud to luxurious solid gold, depending on how wealthy the owner was. The Egyptians were also brilliant farmers. They understood the importance of clean water, fertile land, and efficient planting. They used oxen-pulled ploughs, both heavy ones to dig deep into the soil and lighter ones to smooth it out. After planting seeds, they would send herds of animals walking over the fields to press the seeds firmly into the ground. But none of that would matter without irrigation. The Egyptians were masters of channeling water from the Nile River, using canals and clever techniques that were so effective, other civilizations like the Greeks and Romans copied them. And let's not forget about their marvelous architecture. They built beautiful canals, not just for farming, but also to bring water into towns and cities. Some canals were even lined with decorative structures, making a simple walk along the water feel like a royal procession. One of the greatest builders of them all was Pharaoh Ramesses the Great, a ruler who seemed determined to outdo everyone else. His monuments, temples, and construction projects still stand today as proof of just how skilled and visionary the ancient Egyptians truly were. One of the most jaw-dropping wonders from ancient Egypt is a temple carved right into the rock at a place called Abu Simbel. What makes it so incredible? Twice a year, yes, just 2 times every year, the sun shines straight through the entrance and lights up the statues inside, especially the one of Pharaoh Ramesses. It's like a cosmic spotlight created by some of the earliest architects on Earth. And speaking of brilliant architecture, we can't forget the corbel arch. Without this genius invention, we wouldn't have many of the world's greatest ancient buildings, like the awe-inspiring Great Pyramid of Giza. The Egyptians were true masters of construction. Their temples and palaces weren't just big, they were built with such skill and precision that they still leave people speechless even today. Some of these grand temples even worked as astronomical observatories tracking the movement of the sun and stars. Now, imagine this. Back in school, many of us struggled with strange math terms like sine, cosine, tangent, and that famous number pi. 3.14159. While it may have seemed like nonsense to most students, there's actually a deep and ancient reason behind it all. Believe it or not, the roots of trigonometry, yes, that tricky math with angles, go all the way back to the ancient Egyptians. They needed this knowledge to design and build perfectly angled pyramids. And clearly, they knew what they were doing, because the Great Pyramid in Giza is still standing proud more than 4,500 years later without needing a single repair or call. Now, let's leave the classroom behind and travel back in time, all the way to ancient Egypt. You're standing at the construction site of the Great Pyramid, about 9 miles from where modern-day Cairo now sits. But back then, Cairo didn't exist. All around you is dry desert, and teams of workers are busy moving massive stone blocks. Each of these blocks weighs around 2.5 tons, as heavy as a small car. They're being hauled on wooden sleds which slide over large wooden rollers on the sand. Think of it like the rollers on a checkout counter at a grocery store, but supersized. And the scale is enormous. Experts estimate that the Egyptians used about 2,300,000 of these stone blocks to build just this one pyramid. And the one you're looking at? That's actually a lighter one. Some blocks weighed as much as 15 tons. So, where did all these giant stones come from? Most were taken from quarries near Giza, not far from the building site. That might not sound very impressive until you find out how they transported granite blocks from over 500 miles away. Remember, there were no trucks, trains, or highways back then. But the Egyptians had the Nile River, their ancient highway. Scholars think they even dug a special canal to connect the Nile directly to the pyramid site. During the annual flood season, the river would rise and float the heavy blocks right to where they were needed. Genius, right? But once those blocks reached dry land, how did they lift them up, stacking them higher and higher to form a pyramid? No cranes, no machines, just human strength and smart engineering. Look over there. A worker is pointing to a giant ramp that winds all the way around the pyramid like a spiral. It looks like a mountain road snaking to the top. Why didn't they just build a straight ramp? Because it would have been too steep to pull the stones up. Scientists believe that the maximum slope the workers could manage was around 8%. So instead, the Egyptians made a longer, looping ramp around the pyramid. Some experts even believe the ramp could have been built inside the pyramid. We don't know for sure. This is still one of the greatest secrets of ancient engineering, a mystery that might just be guarded by the Sphinx itself. Speaking of the Great Sphinx, did you know that's not even its real name? That's just a nickname, kind of like a stage name for a singer. Its real ancient Egyptian name means Horus in the horizon, named after a sky god, and there's more to discover. As you walk around the statue, you notice a painter with a bucket of red paint. That's because researchers discovered traces of ancient red pigment near the Sphinx's ear. That paint was so strong, it lasted thousands of years in the scorching desert. Now you're standing right in front of the Sphinx, looking up at its mighty face. It's 66 feet tall, almost as high as a 6-story building. And here's a fun surprise. The Sphinx seems to sit in the center of one side of the Great Pyramid. You're not imagining it. It really lines up perfectly. That's where math comes in again. Pyramids have 4 slanted sides called lateral faces and 1 flat base on the bottom. But since the base is underneath, we don't usually notice it. It's, quite literally, face down. And there's one more mystery the Sphinx holds. Most historians agree it was built by Pharaoh Khafra, who ruled after his father, the builder of the Great Pyramid. That means the 2 great monuments, the pyramid and the Sphinx, were completed around the same time, over 4,500 years ago. So the ancient Egyptians weren't just brilliant builders. They were mathematicians, astronomers, engineers, and artists, all rolled into one. Their creations were not only massive, they were magical, deeply connected to the sun, stars, and the very land they lived on. And all of it was made without the modern tools we take for granted. That's what makes their legacy truly timeless. The ancient Egyptians used a wide range of clever tools and creative techniques to build the mighty pyramids, those awe-inspiring monuments that have stood for more than 4,500 years. These massive structures weren't thrown together with brute force alone. They were carefully planned, skillfully executed, and engineered with astonishing precision. To cut the large limestone blocks used in pyramid construction, workers relied on tools made from copper and bronze. Copper chisels helped them chip away at the soft limestone, while bronze saws, with teeth possibly tipped with harder materials like precious stones, were used to slice through stone more efficiently. These tools had to be sharpened often, as working with stone quickly wore down the edges. Once the heavy blocks were carved out from nearby quarries, the next challenge was moving them. The Egyptians tackled this by using wooden sleds and cylindrical rollers. The idea was simple yet brilliant. Place round logs under a block to roll it forward or pull it along, using sleds across prepared pathways. To reduce friction, they sometimes poured water on the sand in front of the sleds, making the surface slicker and easier to slide across. Long ropes made from woven plant fibres or animal hides allowed large teams of workers to drag the stones with greater force. In some situations, ancient engineers went even further and built pulley systems using ropes and levers. These setups helped distribute the heavy weight so that even smaller groups of workers could maneuver the enormous stones. For long-distance transportation, particularly from distant quarries, the Egyptians built large wooden boats or rafts. During the annual flooding of the Nile River, which happened each summer, these vessels could float close to the construction sites, carrying stones with far less effort than dragging them over land. One of the most important tools in their construction toolkit was the ramp. Ramps made of mud, bricks, rubble, and compacted earth allowed workers to haul stone blocks higher and higher as the pyramid grew taller. There is still debate among experts about what these ramps looked like. Some believe they were straight and stretched out in front of the pyramid. Others think they spiraled around the sides like a giant corkscrew. Whatever their shape, ramps were essential in reaching the pyramid's upper levels. To ensure that everything was placed with incredible accuracy, the ancient Egyptians used simple yet powerful instruments. One of these was the plumb bob, a small weight attached to a string. Because the weight always pointed straight down due to gravity, workers could use it to create perfectly vertical lines. For shaping and smoothing the stones, they used heavy stone hammers and pounders made from dolerite, an extremely hard volcanic rock that could chip away at limestone without breaking. Another tool, the merkit, was used for both astronomy and construction. It worked like an ancient sighting device, and, when paired with a plumb line, helped builders align the edges of the pyramid with stars in the sky. This clever use of stargazing meant that the sides of the Great Pyramid were aligned almost perfectly with the 4 cardinal directions: north, south, east, and west. Their deep understanding of astronomy helped them in other ways too. They closely observed the movement of stars near the celestial North Pole, stars that never set below the horizon. By watching how these stars rotated in the night sky, they could determine the true north with stunning accuracy. This knowledge, combined with basic surveying tools like set squares and ropes marked with knots, allowed them to create right angles and straight lines across large distances. To prepare the pyramid's foundation, the Egyptians waited for the annual flooding of the Nile River. When the floodwaters receded, they left behind flat, wet ground covered in nutrient-rich silt. This soft, level earth made it easier for builders to smooth the surface and carve out a perfectly flat base for the pyramid. The floods didn't just help with construction, they also fed the population by making the surrounding farmlands fertile. With plenty of food, people had time to join large-scale building projects during the dry months. The building of the Great Pyramid of Giza, which was completed over 4,500 years ago, required an enormous effort. While some old stories claim the pyramids were built by slaves, modern research tells a different tale. Most of the workers were actually skilled labourers, stonecutters, engineers, architects, and farmers who worked on the pyramids when they weren't tending their crops. These workers were paid in food, clothing and shelter, and they lived in well-organised workers' villages near the construction site. Historians now believe that between 20,000 and 30,000 people worked on the Great Pyramid at various times. They operated in rotating teams, each group handling a specific job like quarrying, hauling, or masonry. In addition to the main builders, there were thousands of support workers who cooked meals, made tools, repaired sleds, and transported supplies. Altogether, the total workforce may have reached as high as 50,000 people. What is truly remarkable is how well organised this entire operation was. The ancient Egyptians planned everything carefully, from the way they divided the work into manageable sections, to the clever use of geometry, to their systems of measurement. They even marked out grid patterns on the ground to ensure every side of the pyramid was the same length and perfectly straight. Even with no modern machines, no GPS, and no steel, the Egyptians created giant monuments that have lasted for thousands of years. Their work still amazes architects, engineers, and scientists today, not just for its size, but for the intelligence, teamwork, and determination it represents. The pyramids remain some of the most fascinating and mysterious achievements in all of human history. At the very top of ancient Egypt's carefully organised social pyramid were the architects and construction managers. These were highly educated and respected individuals who didn't just draw up the plans for the pyramids, they were the masterminds behind every step of the enormous building process. They guided the entire operation from start to finish, making sure everything went according to plan. Below them were the skilled workers, specialised craftsmen like stonemasons who carved the massive stone blocks, carpenters who shaped wooden tools and supports, and metalworkers who created tools out of copper and bronze. These experts worked with extraordinary care, placing and fitting stones with such accuracy that even today it amazes engineers. The majority of the workforce, however, wasn't made up of full-time builders. Most were regular people, especially farmers, who worked on the pyramids only for part of the year. During the annual flooding of the Nile River, when their farmland was underwater and farming was impossible, these men joined the construction crews. This system gave them work during the flood season and helped provide the huge labour force needed for such monumental tasks. These workers were not just thrown together at random. They were carefully organised into teams called crews and larger groups called files. Each group had specific jobs, whether it was hauling stones, baking bread, mixing mortar or cutting blocks. Instead of being paid with money, the workers were given food, beer and other daily goods. Archaeologists have even found proof that they were well fed and had access to medical care, suggesting they were treated with a surprising level of respect. Recent discoveries have added even more fascinating details. Archaeologists have uncovered evidence of planned worker villages built right next to the pyramid construction sites. These villages included bakeries, breweries, and workshops where copper tools were made and repaired. This shows that the ancient Egyptians not only cared about getting the job done, they also cared for the people doing the work. These findings have changed the way we think about ancient Egyptian labour, showing that it was far more humane and organised than we once believed. To build a pyramid that would stand for thousands of years, the Egyptians had to start with a solid, perfectly flat foundation. First, they dug deep into the ground until they reached solid bedrock. Then they removed any loose sand or debris and filled cracks and holes with crushed limestone chips. But how did they make sure the entire area was level? Their solution was brilliant. They dug shallow channels across the construction site and filled them with water. Because water always finds its own level, they could use it as a natural measuring tool. If the water was deeper in one spot than another, they knew the ground wasn't level there. Workers would then chisel away the high spots, or fill in the low ones with more limestone until the surface was completely flat and even. To check the angles and straight lines, they used a clever tool called a plumb bob. This was simply a weight hanging on a string, but it allowed them to create straight vertical lines and perfect right angles. With this and other tools, like star-aligning devices such as the Merket, they could line up the sides of the pyramid with incredible accuracy, often based on the stars in the night sky. Once the base was ready, the first row of giant stone blocks was carefully placed. These blocks were carved to fit together so tightly that in many places you couldn't even slide a piece of paper between them. Some of the joints were less than a single millimetre wide. The outer casing stones were then polished until they shone like mirrors in the sun, giving the finished pyramid a dazzling appearance. To move the enormous blocks into place, some weighing as much as a small car, the builders used ramps. These ramps were made out of mud bricks or packed earth, and they allowed the workers to drag the stones upward as the pyramid got taller. As each level was completed, the ramps were lengthened or raised so the stones could be hauled even higher. For even more control over where the blocks went, the workers used wooden rollers placed under the stones to help them roll forward. They also used levers made from strong tree trunks. With just a small team and a sturdy lever, they could shift a massive stone exactly where it needed to go. To keep the pyramid's shape perfect as it rose into the sky, the builders created a sort of inner skeleton, a stepped core made of limestone blocks. This core served as a guide, helping workers keep the angle and direction correct as they added more layers. The casing stones were fitted to this inner frame and polished smooth to protect the structure from erosion. At each corner of the pyramid, specially cut blocks called corner sockets were placed at the very beginning. These stones defined the pyramid's angle and alignment, acting as reference points for the entire structure. Throughout the years it took to finish the pyramid, workers constantly checked their progress against these points to make sure the shape stayed perfect. What's most incredible is that all of this, levelling the base, aligning the corners, placing the blocks, was done without modern machines. The Egyptians relied on their deep understanding of geometry, their careful planning, and their tireless effort. Their ability to build such precise and enduring structures over 4,500 years ago is a powerful reminder of just how advanced and capable they truly were. These pyramids still rise above the desert sands today, thousands of years later, as towering symbols of human creativity, determination, and brilliance. One especially popular theory suggests that the pyramids were not made by carving and stacking giant limestone blocks, but instead were built using a kind of ancient concrete. According to this idea, the Egyptians might have mixed crushed limestone with water, lime, and natural salts like natron to form a thick paste or slurry. This mixture could then have been poured into wooden moulds and left to harden into solid blocks right at the construction site. Supporters of this theory believe that it would explain how the stones fit together so perfectly and how such massive structures were completed in what seems to be a relatively short amount of time. Some scientists even say that tiny details seen under a microscope in pyramid stones look more like man-made concrete than naturally formed rock. However, many archaeologists and Egyptologists disagree. They point out that there is strong evidence showing that the stones were actually quarried and transported from known sites using traditional methods. Another more unusual theory proposes that the ancient Egyptians may have used levitation to move the enormous stones. Yes, levitation. According to this idea, the builders might have used sound waves or vibrations in some advanced way, possibly with unknown technology, to lift and float heavy blocks through the air. Some people even believe that this was done with help from beings from other worlds, or by a lost civilization with knowledge far beyond what we currently understand. While this theory sounds like something from science fiction, it continues to inspire books, documentaries, and debates, even though there is no solid scientific evidence to support it. There's also a more down-to-earth but still unusual theory that the Egyptians might have built the pyramids from the top down instead of from the bottom up. This idea suggests that they used complex scaffolding systems and counterweights to place stones from above. If true, it would completely change the way we think about pyramid construction. But this theory hasn't convinced most experts and remains on the fringes of archaeological thinking. Another more recent suggestion focuses on the use of water. According to this theory, the Egyptians may have taken advantage of the nearby Nile River to build a network of canals and water shafts. They could have floated the massive limestone blocks on wooden rafts through water-filled passages, bringing them closer to the building site. As the pyramid grew taller, the water levels in these shafts might have been raised to continue transporting stones to higher points. This method could have made the job much easier by reducing the need for thousands of workers to drag heavy stones across dry land. However, critics argue that there is little archaeological evidence for such a system, and maintaining the required water levels in the dry desert would have been extremely difficult. Among all the alternative ideas, one of the most widely discussed and respected is the internal ramp theory. This theory suggests that instead of using a giant ramp on the outside of the pyramid, the Egyptians built a spiral ramp inside the pyramid's walls. As the pyramid grew taller, workers would carry stones up the spiraling path, which twisted its way through the interior of the pyramid like a hidden staircase. Eventually, when construction was complete, the ramp would have been sealed off or filled in with more stones, becoming a part of the finished structure. This method would have allowed for a steeper incline than an external ramp, saving time, space, and materials. Supporters of the theory also believe that the corners of the pyramid may have been built first, with the ramp winding between them. This would have helped the builders keep the pyramid's shape accurate as it rose higher. Some researchers point to strange patterns and hidden spaces found inside the pyramids that may be signs of such internal ramps. While this theory is not accepted by everyone, it offers a very practical solution to one of history's greatest engineering puzzles. Another idea, closely related to the water transport theory, is known as the water shaft theory. This version imagines that the ancient builders dug deep shafts and tunnels around the pyramid site and filled them with water from the Nile River. These channels could have formed a system of locks, much like those used in modern canals, allowing large stone blocks to float on rafts right up to the construction site. As the pyramid grew higher, the builders could raise the water levels in these shafts, continuing to float stones to the upper levels. This method would have required far less manpower and physical strength than dragging stones up ramps. However, like many of the other alternative theories, it suffers from a lack of clear archaeological evidence. Scholars also question whether the desert environment could have supported such an elaborate water-based system. Beyond these engineering-focused ideas, there are theories that dive into the mysterious and unknown. Some people believe that ancient civilizations possessed powerful technologies that have since been lost to time. According to these claims, the precision of the pyramids or the advanced astronomy of ancient cultures like the Maya must have come from some hidden or forgotten knowledge. However, Historians and archaeologists argue that these achievements can be explained through human ingenuity, hard work, and generations of learning. The tools, techniques, and observations used by ancient people may have been simple by today's standards, but they were extremely clever and effective for their time. There is no strong scientific evidence to support the idea of lost super technologies or vanished advanced civilizations. What we do see in the historical record is a steady and clear growth in human knowledge, not sudden leaps from mysterious sources. However, one of the most imaginative and fascinating theories is the acoustic levitation theory. This idea suggests that sound itself, when controlled in just the right way, could have been used to lift and move heavy stones. It's based on the modern scientific concept of acoustic levitation, where high-pitched sound waves can cause small objects to float in the air. Some theorists wonder if ancient builders may have discovered a way to scale this effect up, using sound chambers or instruments to create powerful vibrations that could lift massive blocks. They also point to ancient stories and myths that mention the use of musical sound in building temples and structures. While intriguing, this idea remains highly speculative. Creating enough acoustic energy to lift stones weighing several tons is far beyond anything we've ever been able to demonstrate, even with modern technology. Most experts still believe that the pyramids were built using physical tools like ramps, pulleys, and human muscle. But the acoustic theory continues to spark the imagination and shows just how many mysteries remain in the story of ancient engineering. Some people believe in a fascinating idea called the ancient aliens theory. According to this theory, beings from other planets may have visited Earth many thousands of years ago and helped early human civilizations build huge and mysterious structures, like the famous pyramids of Egypt. Supporters of this idea think that ancient humans, with their simple tools and limited technology, could not have created such massive and perfectly built monuments all on their own. Those who believe in this theory say that the building blocks used in the pyramids are unbelievably large and heavy, some weighing dozens of tons, and that they were placed with incredible accuracy. The pyramids are also aligned with the stars and the directions of the compass, in ways that seem almost too perfect. To explain all of this, some suggest that aliens shared special knowledge, gave advanced tools, or even helped directly with the construction. But most scientists, archaeologists, and historians do not agree with this idea. Experts have spent many years studying ancient Egypt, and they have found clear evidence showing how the Egyptians developed their own skills and techniques over time. They discovered how to cut huge stones, transport them across great distances using sleds and ramps, and place them carefully to create tall, stable structures. These achievements were made using clever planning, hard work, and teamwork, not alien technology. Although the ancient aliens theory is exciting and fun to think about, it tends to ignore the amazing talents and determination of the ancient Egyptians. The pyramids are not just giant piles of stone, they are powerful symbols of human creativity, organization, and willpower. They remind us what people can do when they work together with a strong vision and purpose. There is another related idea called the theory of advanced ancient civilizations. This theory suggests that long before recorded history, there might have been incredibly advanced societies that had knowledge and technologies far beyond what we usually expect from that time. According to this view, these mysterious civilizations might have known secrets about building that we still don't fully understand today. People who support this idea often point to the Great Pyramid of Giza, built more than 4,500 years ago, as proof. They say its precise measurements, its alignment with true north, within a tiny fraction of a degree, and its complex internal chambers show a level of engineering that would be hard even for modern builders. Some go even further and suggest that the builders may have used secret technologies, like anti-gravity devices or energy tools powered by electricity, to lift and cut the giant stones. One of the more unusual versions of this idea suggests that sound itself might have played a role in pyramid construction. This theory, called acoustic levitation, says that the ancient Egyptians may have discovered how to use certain sound frequencies to lift heavy objects. The idea is that sound waves, when tuned just right, could create a kind of invisible force that pushes against gravity, allowing people to float massive blocks through the air. Supporters believe that ancient builders might have used special instruments or chanting to control this mysterious power. While this idea is fascinating and imaginative, scientists say it is very unlikely. The amount of sound energy needed to lift something as heavy as a stone block would be enormous, and there is no real evidence that people in ancient times had this kind of ability or technology. Most archaeologists believe that the Egyptians used much simpler methods, like wooden sledges, ropes, and large teams of workers to get the job done. Still, the fact that so many people are interested in these unusual theories shows just how much mystery still surrounds the pyramids. The thought of lost knowledge, forgotten civilizations, and strange possibilities continues to capture our imaginations. Another amazing thing about the pyramids is how carefully they are aligned with the stars and the directions of the Earth. Some believe that this alignment is too accurate to be a coincidence. For example, the Great Pyramid of Giza is lined up almost perfectly with the north direction, off by only a tiny sliver of a degree. Some people think this shows that the Egyptians had a very deep understanding of astronomy, or perhaps they inherited knowledge from an earlier unknown civilization. There is also a theory that says the layout of the three pyramids at Giza matches the shape of the three stars in Orion's belt, a famous part of the night sky. Supporters of this idea believe the pyramids were built as a kind of star map, and that they were meant to link the souls of the dead pharaohs with the gods of the heavens. This idea adds a spiritual or symbolic meaning to the way the pyramids were built and placed. Most professional Egyptologists and archaeologists, however, believe that the Egyptians managed these precise alignments through careful observation of the sky and the use of simple tools. They likely watched the movements of the sun and stars over long periods and developed methods to measure and mark directions with surprising accuracy, even without modern instruments. Even though these alternative theories, whether about aliens, ancient technologies, or sound-powered levitation, are very imaginative, the majority of experts agree that the pyramids were created by human hands using human ingenuity. The real story of how these magnificent monuments were built may not involve outer space or lost superpowers, but it is still full of wonder. It speaks to the brilliance, patience, and determination of a civilization that lived thousands of years ago, leaving behind some of the greatest wonders the world has ever seen. Just outside the bustling city of Cairo in Egypt, a group of enormous stone structures rises from the desert sands, majestic, mysterious, and incredibly old. These are the Great Pyramids of Giza, built over 4,500 years ago during a period known as the Old Kingdom of Ancient Egypt. Though time has passed and empires have risen and fallen, these giant tombs still stand, watching silently over the land of the Nile. There are three main pyramids at the Giza Plateau. The biggest and most famous is called the Great Pyramid of Khufu, also known by the Greek name Cheops. At the time it was completed, this pyramid stood at a towering height of about 146 meters. That's taller than a 40-story building. Incredibly, it held the record for the tallest human-made structure on Earth for more than 3,800 years. Just imagine, no one built anything taller for nearly 4 whole millennia. The Great Pyramid was built using around 2,300,000 massive limestone blocks, and each one weighed an average of 2.5 tons, about as much as a large car. How the ancient builders managed to move and place these stones with such stunning precision still puzzles experts to this day. The effort, planning, and brain power that went into this project were nothing short of astonishing. Next to the Great Pyramid are 2 other Grand Pyramids. The second largest was built for Pharaoh Khafra, the son of Khufu. Although it is slightly shorter than his father's pyramid, it was built on higher ground, making it appear just as tall, or even taller. The third pyramid, the smallest of the 3, was built for Pharaoh Menkaure, Khafra's son. But don't let the word smallest fool you. It's still an enormous structure that would leave most modern buildings in its shadow. Guarding this incredible complex is the Great Sphinx, a massive statue carved from limestone with the body of a lion and the face of a human, possibly even that of Khafra himself. This iconic figure only adds to the mysterious and magical atmosphere of Giza. The entire pyramid complex, known as the Giza Necropolis, includes not just the 3 main pyramids, but also smaller ones, temples, and many tombs. All of these were created for one powerful purpose: to serve as resting places for the pharaohs and to help them on their journey into the afterlife. The ancient Egyptians had a rich and complex belief system. They believed that death was not the end, but just the beginning of a new life. To prepare for this journey, they built the pyramids as eternal homes for their kings, filled with everything the ruler might need in the next world. Construction of the Great Pyramid of Khufu is believed to have begun around 4,600 years ago, during what historians call the Fourth Dynasty. Experts believe the Great Pyramid was built between 2,560 and 2,540 years before the Common Era. The Pyramid of Khafra came shortly after, around 2,520. Before the Common Era, followed by the Pyramid of Menkaure, completed around 2,490 before the Common Era. These dates are not just guesses. They come from radiocarbon dating of organic materials like wood and from ancient Egyptian writings and records. Together, they tell the story of one of the greatest construction projects the world has ever seen, one that took many decades to complete and required an astonishing level of organization. For centuries, people thought the pyramids were built by slaves, toiling under harsh conditions. But more recent archaeological discoveries tell a very different story. It now seems that the labourers were well-fed, skilled workers who were paid for their efforts. They lived in nearby workers' villages, and they were proud of what they were doing, building monuments that would last forever. It's believed that it took about 20 years to complete the Great Pyramid alone. That's a generation of people dedicating their lives to a single project. Just think of the coordination it would have taken. Architects, stonecutters, engineers, artists, planners, and thousands of workers all moving in perfect harmony to make the pharaoh's grand vision a reality. After this golden age of pyramid building, which reached its peak with the Giza pyramids, the construction of new pyramids began to slow down. Later pyramids were smaller and less impressive, and the focus of royal tombs eventually shifted to hidden burial chambers in the Valley of the Kings. Even today, more than 4,500 years later, the pyramids of Giza continue to inspire awe. We still don't fully understand how they were built, how those enormous stones were moved, how the alignment is so precise, or how the architects managed to create such perfect shapes on such a gigantic scale. These mysteries keep scientists, historians, and curious minds around the world asking questions. More than just tombs, the pyramids of ancient Egypt were powerful symbols of the pharaoh's greatness, their connection to the gods, and their dreams of eternal life. Built during the Old Kingdom and Middle Kingdom periods, starting over 4,500 years ago, these enormous stone structures were designed to do more than hold a body. They were meant to last forever. The pyramid shape was not chosen by accident. Many historians and scholars believe it may have represented the sun's rays stretching down to earth. Since the pharaoh was seen as the living son of the sun god, Ra, this shape allowed his spirit to climb back up to the sky after death, returning to the divine realm. Inside each pyramid, there were narrow corridors, secret chambers, and beautifully crafted rooms. Deep within, the pharaoh's body, carefully preserved through mummification, was surrounded by everything he might need in the afterlife. This included food, water, fine clothes, golden jewellery, royal furniture, and even full-sized boats for sailing in the next world. The pyramid wasn't built alone either. Around the main pyramid were smaller ones for queens, temples for ceremonies, and special areas for priests to leave offerings and keep the memory of the pharaoh alive. But building these mighty structures wasn't just a religious or personal act, it was also political. Organising such a massive project required huge amounts of stone, wood, food, and tools. Thousands of skilled workers, craftsmen and labourers had to work together for many years. This united the country under the leadership of the pharaoh and strengthened the idea that he was not just a ruler, but almost like a god on earth. Among all the pyramids, the Great Pyramid of Giza is the most famous and the most extraordinary. Built for Pharaoh Khufu, who ruled around 2,560 years before the Common Era, it is one of the greatest monuments ever made by human hands. When it was first finished, it reached a height of about 480 feet, or 146 meters. That's roughly as tall as a modern 45-story building rising from the desert sands. Even now, after more than 4,500 years, it still stands at around 450 feet tall, though it has lost its smooth white casing stones over time. The Great Pyramid was so tall and well built that it held the title of the tallest man-made structure in the world for nearly 4,000 years. That record wasn't broken until the 19th century, when modern buildings finally reached greater heights with the help of steel, cranes, and electricity. The pyramid wasn't just tall, it was built with incredible precision. Its sides are aligned almost perfectly with the four main directions: north, south, east, and west. Its height and base form a special mathematical ratio that shows just how advanced the ancient Egyptians were in geometry and measurement. It's almost as if they had knowledge that was far ahead of their time. What's even more amazing is the sheer weight of the pyramid. This mighty monument weighs about 6 million tons. That's the same as around 15,000 jumbo jets fully loaded and ready for takeoff. To create it, the builders had to move about 2.5 million blocks of limestone, with each stone weighing around 2.5 tons. Some of the blocks inside the pyramid, especially the granite ones in the inner chambers, weigh up to 80 tons each. And remember, all of this was done without cranes, trucks, or power tools. The workers used copper tools, ropes, wooden sleds, and clever engineering tricks. They even built massive ramps made of mud bricks to move the stones higher and higher as the pyramid rose toward the sky. The materials they used were carefully chosen. Most of the pyramid was built from limestone, which was plentiful and easy to shape. For the important parts, like the entrance passages and burial chambers, they used tough granite, which was much harder to cut but provided strength and protection. This granite had to be transported from Aswan, more than 800 kilometers to the south, a journey that took great effort and planning. They also used wood, especially cedar and other hardwoods, to build sleds, levers, and rollers for moving the heavy blocks. Mortar, made from lime, sand, and water, helped fill gaps and hold the stones together. Though we still don't know exactly how the ancient Egyptians lifted such enormous stones into place, it's clear that they had remarkable skills in architecture and planning. Most experts believe that building the Great Pyramid took about 20 to 30 years, and that as many as 100,000 people may have worked on it. These weren't just slaves, as once believed. Many were skilled labourers, engineers, stonecutters, and farmers who worked during the Nile's flood season when farming was impossible. But the pyramid wasn't only about showing off the pharaoh's power, it also had deep spiritual meaning. Pharaoh Khufu believed that his soul would live on forever, and the pyramid was his gateway to the next life. Inside it, his body and belongings would be safe for eternity. Outside it, temples and priests would keep his memory alive through ceremonies and offerings. However, the Great Pyramids of Giza are not just dusty piles of stone in the desert. They are masterpieces of human creativity, determination, and belief. They show what people can do when they work together with a common goal, and they remind us of the ancient Egyptians' rich culture, their passion for life after death, and their love of the divine. That's why the Great Pyramid still holds a place among the 7 wonders of the ancient world, and why, even after 4,500 years, it continues to leave us speechless. Deep within the towering Great Pyramid of Giza, there are long, narrow tunnels that have fascinated and puzzled archaeologists and historians for many generations. These small shafts, often called air shafts, are not really for ventilation at all. Instead, they stretch out from 2 special rooms inside the pyramid, the King's Chamber and the Queen's Chamber, and point towards specific stars in the night sky as it looked to the ancient Egyptians thousands of years ago. One of the most fascinating ideas about these shafts is that they were made for spiritual reasons. Many scholars believe they were meant to guide the soul of the dead pharaoh up into the heavens. The northern shaft from the King's Chamber points toward the circle of stars that never set, called the circumpolar stars. The Egyptians believed these stars never dying meant eternal life. The southern shaft from the King's Chamber lines up with Orion's belt, a group of stars linked to the god Osiris, who ruled over the afterlife in Egyptian mythology. The Queen's Chamber shafts are even more mysterious. One points toward those same eternal stars in the north, while the other seems to align with Sirius, the brightest star in the night sky. The ancient Egyptians connected Sirius with the goddess Isis, wife of Osiris, and used it to help mark the start of their calendar each year when the Nile River would flood. Some people believe these shafts helped the pharaoh's soul rise to the stars to join the gods. Others think they might have had more practical uses. Maybe they were used to help workers lower or lift stones, or even observe the stars. Whatever their true purpose, the shafts are amazingly accurate and carefully made, showing the Egyptians' deep knowledge of the stars and their extraordinary skills in building things with stone. The king's chamber itself is one of the greatest marvels of ancient engineering. It was built using huge blocks of granite that were brought all the way from Aswan, a city over 500 miles to the south of Giza. These enormous blocks, some weighing as much as 70 tons, were floated down the Nile River on massive wooden boats during the time of year when the river was high. Once the stones reached Giza, workers used clever tools and methods to move them into place. They probably used wooden sleds, long ramps, and levers. To cut and shape the hard granite blocks, they used copper chisels and bronze saws fitted with teeth made from even harder stones. Some researchers believe they also used pulleys and counterweights to lift the stones into position. The builders paid incredible attention to detail. They used simple tools like plumb bobs, set squares, and levels to make sure everything was perfectly straight and aligned. One of the tricks they used was called corbelling, where each layer of stone is set a little further inward than the one below it. This made the chamber's ceiling strong enough to hold up the enormous weight above it. The craftsmanship in the king's chamber is truly jaw-dropping. The blocks are fitted together so tightly that not even a thin piece of paper or a credit card can fit between them. And remember, this was done more than 4,000 years ago. Even today, engineers and architects are amazed by how precise the ancient Egyptians were with such simple tools. The Great Pyramid is full of mysteries like this. Those tiny shafts, for example, are just one part of its amazing design. They might look small, but they connect deep beliefs about the afterlife with the stars above and the structure itself. Another mystery is the strange emptiness inside the pyramid. Unlike many other ancient tombs, the inside of the Great Pyramid has no carvings, no paintings, and no hieroglyphics. It is bare stone, completely undecorated. This makes it stand out from other pyramids built later, which were filled with colourful images and writings. One idea is that the Great Pyramid was built during a time, around 2,550 years before the birth of Christ, when the focus was more on the pyramid itself than on decorations. The structure was the message. It was meant to last forever and protect the pharaoh's soul. Some experts also think the way the pyramid was built may have made decorating the inside impossible. It was built in layers from the inside out, so once the stones were in place, there was no way to go back and decorate the walls. And since the outside was once covered in smooth, shiny white limestone, maybe the builders felt that was all the decoration it needed. Others wonder if there were once decorations that got destroyed or taken away over time, but no traces of paint or chisel marks have ever been found to support that theory. So for now, the emptiness remains one more mystery. Beneath the pyramid lies another strange and puzzling part, the subterranean chamber. This hidden room is carved into the bedrock about 100 feet below the base of the pyramid. It has rough, unfinished walls and floor, and no one knows exactly why it was made. One theory says it was supposed to be the pharaoh Khufu's original burial chamber, but the plan changed during construction. Maybe the workers ran into problems, or maybe religious beliefs shifted. The unfinished look of the room makes this idea seem possible. Another idea is that this underground room had a symbolic meaning. In Egyptian belief, the underworld was a dark, deep place beneath the earth. Perhaps this chamber was meant to represent that part of the journey, the place where the pharaoh's soul would pass before rising to the sky. Others suggest more practical uses. Some say it might have been a storage space for treasures or supplies for the afterlife, or perhaps it was part of the construction process, used to help align the pyramid or even to store water. But just like the rest of the Great Pyramid, the true purpose of the subterranean chamber remains unknown. Every stone, every shaft, and every chamber inside this ancient wonder continues to raise new questions, reminding us how advanced and mysterious the civilization of ancient Egypt truly was. The ancient Egyptians showed an incredible level of skill and care when it came to preparing the base of the Great Pyramid. Long before they ever started stacking stones, they had to make sure that the ground was perfectly flat. And they didn't just eyeball it. They used smart engineering and careful craftsmanship that still impresses experts today. They began by closely examining the natural limestone bedrock of the Giza Plateau. Any bumps, slopes, or rough patches in the stone were carefully identified. Workers then chipped away at the high spots using copper chisels and bronze saws that had sharp, dual-tipped teeth. It was slow, hard work, but it allowed them to gradually smooth out the entire area. To make sure the surface was level, they dug shallow trenches and filled them with water. Since water always finds its own level, this clever method acted like a very early version of a leveling tool. To make things even more precise, the Egyptians used a smart technique known today as true leveling. They carved out a network of channels in the bedrock and poured water into them. Then they marked the water lines on the sides of the channels. Any stone that stood above that line was removed until the whole surface matched the water level. This method helped them create a base so flat that the difference in height across the entire area was less than half an inch. That's less than the thickness of a finger, across a space of about 13 acres. To finish the job, they filled in any small dips or low areas with blocks of limestone, fitting them carefully so they sat perfectly level with the surrounding ground. Then came a final touch, a beautiful layer of white limestone casing stones. These were polished until they shone like mirrors, reflecting the sun and giving the pyramid a dazzling appearance. This level of precision created a strong, steady foundation that allowed the pyramids to last for thousands of years. Now let's look inside the pyramid, specifically at a hidden structural marvel, the relieving chambers above the king's chamber. These 5 empty rooms, stacked one on top of the other, were built for a very important reason. The huge blocks of stone making up the pyramid put an incredible amount of pressure on the rooms below. Without protection, the ceiling of the king's chamber could have collapsed under all that weight. So, the Egyptians built these special chambers using enormous beams of granite. The lowest of these rooms even had a triangular or peaked roof, designed to push the weight away from the middle and out toward the sides. This clever design meant that the heavy mass of the pyramid was carried safely around the chamber instead of crushing it. But these chambers aren't just engineering marvels, they also give us a rare peek into how the pyramid was built. On the walls, workers left behind red ink markings, showing the names of crews and perhaps even construction instructions. These markings are like time capsules from over 4,500 years ago. Some people also believe the relieving chambers might have deeper meanings. Maybe they were part of the Egyptians' spiritual beliefs, or even aligned with stars or other astronomical features. Whatever the case, these mysterious spaces continue to fascinate both scientists and history lovers alike. Inside the pyramid, the king's chamber stands out for another reason. Its powerful building material, granite. Unlike the softer limestone used in most of the pyramid, granite is extremely tough. The Egyptians chose it on purpose to guard what they believed was the pharaoh's most sacred space. Granite could handle the crushing weight of millions of stones above it, and was much harder for tomb robbers to break into. But granite wasn't just strong, it was also symbolic. The Egyptians believed its reddish colour represented the sun and rebirth. These were key ideas in their religion, especially when it came to life after death. By using granite in the king's chamber, they were showing that this room was meant for someone divine, the pharaoh himself. Meanwhile, limestone, which was easy to find nearby and much easier to shape, made up most of the pyramid's body. It was light, sturdy, and plentiful. The Egyptians carefully combined the right materials for the right jobs, balancing strength, symbolism, and practicality. Their smart choices helped the pyramid stand the test of time, and today, the Granite King's Chamber is still one of the best preserved parts of the entire monument. Now let's talk about one of the most puzzling parts of the pyramid, the so-called door inside. At the end of a narrow shaft that leads out from the Queen's Chamber, explorers found a small stone slab fitted with copper pieces. At first, people thought it might be a secret door, and theories exploded. Was it hiding a treasure? A burial chamber? A message from the past? When researchers sent tiny robots into the shaft, they discovered that this wasn't really a door after all. It was a blocking stone. The copper handles weren't handles at all, but may have been for ceremonial or decorative purposes. Even more intriguing, behind this stone there was another small chamber. What's inside it? That's still a mystery. Some experts think these shafts were meant to guide the spirit of the pharaoh up to the stars, helping him join the gods in the afterlife. Others think they were used for ventilation or aligned with certain stars for religious or cosmic reasons. Whatever the truth is, these secret shafts and doors remind us how much we still don't know about the Great Pyramid. Now, let's look at something truly amazing: how precisely the ancient Egyptians cut and fit the massive blocks of stone. The way the blocks fit together is so perfect that even today, you can't slide a knife blade between them. They achieved this by using simple but clever tools. Copper chisels and bronze saws, along with sand for grinding, allowed them to cut even the hardest stones like granite. First, workers roughly shaped the blocks. Then they used a method called truing. This meant rubbing two blocks against each other with sand in between, slowly wearing them down until both surfaces were perfectly flat. For the tightest joins, especially in temples or important tombs, they used water and light. They poured water between blocks and looked at how the light reflected off the water's surface. If the reflection wasn't perfect, it meant the surface wasn't flat, and they kept smoothing until it was. To make sure everything was straight and level, they also used tools like plumb bobs, simple weights hanging on strings, and stretched cords across the building site to mark level lines. These methods helped them maintain incredible precision, even over large areas. Thanks to their creativity, patience, and sharp eyes for detail, the Egyptians built structures so exact that they still puzzle modern engineers. And despite the passage of more than 4,500 years, many of these joints are still holding strong, just like the memory of the civilization that made them. Over the years, archaeologists have uncovered some truly puzzling objects and structures, things that seem to hint that ancient people might have been far more advanced than we usually think. These discoveries have sparked curiosity and debate, raising big questions about what kinds of technologies ancient civilizations may have possessed. One especially curious object is known as the Baghdad Battery. It was found in modern-day Iraq and is believed to date back to the time of the Parthian Empire, which existed over 2,000 years ago. The battery is made up of a clay pot, a copper tube, and an iron rod. Some scientists believe that, when filled with a kind of acidic liquid like vinegar or lemon juice, this setup could have produced a small electric current, much like a very simple battery. Although there's still debate over its true purpose, it has become a symbol of the mystery surrounding ancient knowledge. In Egypt, the Great Pyramid of Giza continues to amaze engineers and researchers, even though it was built more than 4,500 years ago. The stone blocks used in its construction are enormous, some weighing as much as 70 tons, and they were cut, shaped, and placed with such incredible accuracy that the gaps between them are often less than the width of a single millimetre. That level of precision would be impressive even today with modern machinery, so it leaves us wondering, how exactly did the ancient Egyptians do it? Some believe the answer might lie in forgotten or lost technologies. These could include specialised tools or instruments that were used to measure, cut, and transport the stones with astonishing precision. Others go further, suggesting that the Egyptians may have had construction methods we have never even imagined. Perhaps ways of moving huge blocks using clever tricks of physics, or even manipulating gravity in ways that sound like science fiction. Meanwhile, in ancient India, texts like the Mahabharata and Ramayana describe mysterious flying machines known as vimanas. These ancient scriptures speak of aerial battles and machines that could fly through the sky, or even journey between planets. While mainstream scholars usually treat these stories as mythology, the detailed descriptions of how these machines were built and operated have led some people to wonder, could they be based on real technologies that have been lost over time? From Greece comes another fascinating artifact, the Antikythera mechanism. This device, which was discovered in the remains of a shipwreck and dates back to around 150 to 100 years before the birth of Christ, is often called the world's first analog computer. It used a complex system of gears to track the movements of the sun, moon, and planets, and to predict eclipses with incredible accuracy. For something so ancient, it shows an astonishing level of mechanical engineering. These discoveries, and many others, have led some researchers to propose a bold idea that ancient civilizations might have had technologies far more advanced than what we usually believe. While this view is still controversial, it continues to gain interest, especially among those who study ancient texts and artifacts from around the world. Take the construction of the pyramids, for instance. For centuries, people have wondered how the ancient Egyptians were able to build such massive and perfectly aligned structures using only the tools available at the time. Some thinkers suggest that the Egyptians might have used advanced surveying tools to align the pyramids with the stars or the cardinal directions. Others imagine that they had access to powerful cutting tools made from materials we no longer understand, which would explain how they were able to shape granite blocks with such smooth and precise edges. Then there are even more speculative ideas. Some believe that machines or devices may have existed that could reduce the weight of heavy stones or use the wind or water in creative ways. One theory suggests that large wooden rafts and rising water levels could have helped workers float the stones into place. Another intriguing idea is the use of giant kites, harnessing strong desert winds to help lift and move the blocks. These theories may sound far-fetched, but they all point to one thing. Ancient builders were incredibly inventive, and their methods, while still debated, show a level of problem-solving that continues to inspire awe. There are also unusual artifacts and ancient writings from around the world that seem to hint at forgotten knowledge or even extraterrestrial influence. In the stories of ancient Sumeria, the Anunnaki were powerful beings who came down from the sky and brought knowledge to humanity. In the Bible, the prophet Ezekiel describes a strange flying object made of shining metal, which some believe sounds like a spaceship. The destruction of the cities of Sodom and Gomorrah has even been interpreted by some as resembling a nuclear explosion. And in Greek myths, the tale of Daedalus and Icarus, who built wings to fly through the sky, may be more than just a symbolic story. It might be a distant memory of early experiments in aviation. The legend of Atlantis, described by the philosopher Plato, tells of a highly advanced civilization that vanished mysteriously. Many imagine it as a place filled with incredible technologies that were lost to time. One particularly captivating theory suggests that the ancient Egyptians may have known how to use electricity. Some researchers point to a carving found in the Temple of Hathor at Dendera, which looks a bit like a modern-day light bulb. These same researchers suggest that jars similar to the Baghdad battery could have been used to create small electric currents, possibly to power lamps. They also note the absence of soot on the ceilings of many tombs, which would have been left behind if torches or oil lamps were used. However, most archaeologists and Egyptologists disagree with this theory, saying that such interpretations are likely the result of reading too much into symbolic artwork or taking images out of context. Still, the idea of ancient electricity continues to fire the imagination of many people. Could ancient people have discovered something we've since forgotten? Another overlooked aspect of ancient engineering is the use of magnetism. Some researchers believe that early builders may have used naturally magnetic stones, called lodestones, as compasses to find magnetic north. By floating one on water or hanging it from a string, they could determine direction with surprising accuracy. This would have been very helpful when trying to align temples, pyramids, and other monuments with the stars or the cardinal points. In some cultures, aligning buildings with magnetic north may also have had spiritual or cosmic significance. There's even speculation that the magnetic properties of certain stones might have influenced their selection for use in special buildings or sacred sites. Of course, the ancient Egyptians didn't have real levitation like in science fiction movies, but that doesn't mean they didn't use incredibly clever techniques to achieve results that seem almost magical. They used ramps, levers, and counterweights to move enormous blocks of stone. Some theories propose that they may have used water channels to float the stones closer to their final positions, reducing the effort needed to drag them across dry ground. All of these theories, whether practical or imaginative, show one thing very clearly. The people of the ancient world were brilliant thinkers and problem solvers. Their knowledge of astronomy, engineering, physics, and nature allowed them to achieve astonishing feats that still baffle us today. Even though mainstream archaeology remains cautious and insists on solid scientific evidence, the ongoing exploration of ancient technologies opens up a world of fascinating possibilities. Whether these achievements were the result of lost knowledge, forgotten inventions, or simply brilliant human ingenuity, they remind us of just how much there is still to learn about the people who came before us. Long ago, ancient civilizations had a surprisingly deep understanding of sound and vibration, far beyond what we might expect. This knowledge wasn't just used for music or rituals. It may have played a powerful role in how they built their great stone monuments. In fact, some experts believe that ancient people used sound and vibrations not only to shape their buildings' acoustics, but possibly even to help move enormous stone blocks, without modern machines. Take the amphitheatres built thousands of years ago by the Greeks and Romans. These open-air theatres were carefully designed so that even the softest whisper on stage could be heard clearly by people sitting all the way in the back row. The builders achieved this by cleverly shaping the seats, stage, and walls to guide sound waves in just the right way. Their mastery of acoustics, how sound travels, still amazes modern scientists and architects. It shows that these ancient cultures knew a lot about the science of sound, even if they didn't describe it the way we do today. Some researchers go even further and suggest that ancient builders might have used vibration to reduce friction when dragging heavy stones. According to this idea, they could have applied specific sound frequencies to create a cushion of air under the block, like a primitive form of hover technology. This thin layer of air would have made the stone easier to slide across the ground. Though this idea is still just a theory, it offers a fascinating possibility for how ancient people might have moved stones weighing many tons with such apparent ease. The idea of resonance, which is when an object naturally vibrates at certain frequencies, might also have played a part. Ancient builders could have used this knowledge to design buildings that were more stable during earthquakes. By matching the vibrations of the structure to the ground's natural movement, the buildings could sway safely without collapsing. Resonance might even have helped in settling a foundation more firmly into the earth. This shows us that the people of the ancient world might have had a much more advanced understanding of physics and engineering than we usually give them credit for. Moving from sound to metal, the ancient Egyptians were especially skilled in working with copper and other metals. Archaeologists and engineers are still impressed by the advanced metalworking techniques these people used, especially when building the mighty pyramids. One possibility is that they had discovered ways to mix copper with other elements to create tougher, more durable tools. These special copper alloys might have allowed them to cut through the massive limestone blocks used to build the pyramids with surprising precision. Another fascinating theory suggests that the Egyptians may have known how to use electroplating, a technique that uses electricity to coat one material with a thin layer of metal. If this is true, they could have covered some parts of the pyramids with shiny layers of gold or other metals, giving them a smooth, mirror-like finish. Over thousands of years, these layers might have worn away, leaving behind only weathered stone. There is also the possibility that ancient builders knew how to cast large metal parts with incredible accuracy. If they had used metal molds or guides during construction, this could explain how the stone blocks fit together so perfectly, sometimes so tightly that not even a piece of paper can slide between them. Even more intriguing are discoveries of ancient Egyptian tools and artifacts that show signs of advanced welding techniques. These methods could have helped them join metal parts together or create tools strong enough to work on the hardest stones, such as granite. Combined with possible heat treatment, which involves carefully heating and cooling metal to make it stronger, these techniques reveal a level of craftsmanship that was far ahead of its time. Some bold and unconventional thinkers have taken these ideas a step further. They propose that the ancient Egyptians may have had knowledge of how to manipulate gravity, allowing them to lift and position gigantic stones without needing thousands of workers. According to this theory, they might have used sound waves to create acoustic levitation. By generating certain vibrations, they could have reduced the weight of the stones, or even lifted them off the ground completely. Supporters of this idea often point to mysterious hieroglyphs in ancient writings, claiming they contain hidden clues about lost technologies. When interpreted through a modern scientific lens, these texts are said to describe principles of sound physics and anti-gravity effects. However, it's important to approach such theories with caution. Most scientists and historians agree that there is no solid evidence to prove these ideas. Mainstream experts believe the pyramids and other ancient marvels were built through incredibly clever but conventional methods. These included large teams of workers using ramps, levers, sleds, and a strong understanding of mathematics, engineering, and teamwork. Still, whether they used vibrations, metals, or just muscle power, one thing is clear. The people of the ancient world were brilliant engineers and inventors. Their monuments still stand today as silent, awe-inspiring proof of what humans can achieve, even without the technology we now take for granted. What's even more astonishing than the size and precision of these structures is the fact that they were built using tools made mostly from copper and bronze, metals much softer than the hard stones used in the construction. At the heart of their building efforts were copper chisels. These tools, made from copper or copper alloys, were used to shape and carve the limestone blocks that formed the bulk of the pyramid walls. Though copper may seem too soft to cut stone, it was perfect for limestone, which is a relatively soft rock. Skilled workers would sharpen these chisels frequently to keep them in good working condition, using them to trim rough blocks into perfect fits. Copper saws were another important tool. These were long-toothed blades that allowed workers to slice through softer stones with surprising accuracy. The saws didn't act alone, though. Workers would often use sand, especially quartz sand, alongside the saws. This sand, harder than copper but softer than the stone, acted as a powerful abrasive. As the saw moved back and forth, the sand helped grind down the stone, slowly cutting through it with remarkable precision. To smooth the surfaces or shape wooden beams used in construction, the Egyptians used copper adzes. These tools looked like a mix between an axe and a hoe, and were ideal for scraping and refining surfaces. For moving and lifting huge limestone blocks, they used copper grappling hooks tied to ropes. These gave them extra control and leverage, especially during the delicate process of positioning blocks high up in the pyramid walls. Smaller tools like copper hammers and mallets were used for detailed work, such as carving fine decorations in the temples and tombs around the pyramids. These tools were less about brute force and more about finesse, allowing artisans to produce the stunning artistic details that still survive today. For tougher jobs, such as working with granite, a stone far harder than limestone, the Egyptians turned to bronze tools. Bronze, made by combining copper with tin, was the strongest metal they had before the discovery of iron. But even bronze couldn't slice through granite on its own. So the Egyptians came up with a clever trick. They used bronze saws together with sharp sand. The sand did the real cutting, while the saw helped guide and press the grains into the stone. This method took time, but it worked beautifully. When they needed to split granite blocks rather than saw through them, they used an ingenious combination of bronze chisels, hammers, wooden wedges, and water. First, workers would drill holes in a line across the stone. Then, they inserted dry wooden wedges into each hole and poured water over them. As the wood soaked up the water, it expanded with great force. This pressure caused the granite to crack right along the line of holes. It was a slow process, but one that allowed them to break apart enormous blocks without needing modern machines. There's a common myth that the ancient Egyptians used diamond-tipped drills to carve their stone, but no real evidence supports this. People may assume this because the Egyptian stonework is so precise, it seems almost impossible without high-tech tools. But archaeologists have found no signs of diamonds, only copper, bronze, stone tools, and the occasional bit of hardened sand. Modern experiments have proven that these ancient techniques really work. With enough patience, copper tools and sand can indeed cut through even hard stones like granite. All of this points to a simple truth. The Egyptians were not just building pyramids, they were engineering marvels with simple tools and brilliant minds. Another fascinating method the Egyptians might have used involved water and the power of freezing temperatures. Workers would carve a series of grooves or holes into a stone, then fill them with water and seal them. As night fell and the temperature dropped, the water inside the holes would freeze and expand. This expansion, about 9% in volume, generated tremendous pressure, slowly cracking the rock along the desired lines. Over several nights, this freeze-thaw process would split the stone in a natural and controlled way. While this technique required patience and a good understanding of nature, it provided a powerful, low-tech way to break apart massive blocks. But before those stones ever made it into place, they had to be transported across great distances. This was no small task, especially without wheels or engines. To do this, ancient engineers used a clever combination of wooden rollers and wooden sleds. Rollers were simply logs cut into round shapes. Workers placed them under the heavy stone blocks, and as the block rolled forward, they would move the rear rollers to the front, creating a constant cycle. This reduced friction, and made it possible to move blocks weighing several tons using only human strength. Sleds, on the other hand, were flat wooden platforms that helped spread out the weight of a stone block. These sleds were pulled by teams of workers, or in some cases, animals. To make things easier, builders often poured water or mud on the ground in front of the sled. This made the surface slippery, reducing friction and helping the sled glide more smoothly, especially when going uphill or over rough terrain. Together, the use of rollers on firm ground and sleds on soft or uneven paths created a flexible and reliable way to move stones from the quarries to the construction sites. This combination of ingenuity, teamwork, and clever thinking helped turn millions of heavy stones into the towering pyramids we still marvel at today. The ancient Egyptians were not just skilled labourers, they were brilliant inventors and master engineers. To build their awe-inspiring pyramids and temples, they came up with clever methods that helped them do what seemed almost impossible: lift and move gigantic stone blocks, some weighing several tons. One of the most remarkable techniques they likely used was something called the counterweight system. This system worked on a very simple idea. If you hang a heavy weight on one side of a rope or a beam, it can help lift something just as heavy on the other side. Imagine a giant seesaw. When one end goes down, the other rises. By using this idea, the Egyptians could lift huge stones without needing hundreds of people to drag them. Archaeologists believe that the Egyptians may have used long wooden beams as levers. On one end of the beam, they would tie a heavy stone as a counterweight. Workers would then push down on the longer end of the beam, which caused the opposite end to rise, lifting another heavy block bit by bit. As the stone rose, they would shift the balance point to the fulcrum, making it easier to inch the block upwards toward its final position. Another smart way they might have used counterweights was in building ramps. Instead of dragging heavy stones uphill with pure muscle, they could attach stones to sleds and use ropes connected to counterweights. These would pull the sleds up inclined ramps more easily, saving a lot of energy and manpower. This method would have been especially helpful for lifting stones to higher levels as the pyramids grew taller. But it wasn't just brute force that made pyramid construction possible. The Egyptians were also mathematical geniuses and expert surveyors. The precision they achieved is truly mind-blowing, even by today's standards. Take the base of the Great Pyramid of Giza, for example. Each side of this massive square measures more than 230 meters, and yet the difference in length between the sides is just a few centimeters. That kind of accuracy would be difficult even with modern laser tools. To achieve such straight lines and perfect angles, the Egyptians must have used advanced measuring instruments. They may have used simple but effective tools like plumb bobs, sighting poles, and ropes stretched tightly to create perfect right angles and long, straight edges. They also seem to understand the stars and the movement of the sun incredibly well. The Great Pyramid is aligned almost perfectly to the four cardinal directions: north, south, east, and west. This suggests that they knew how to observe the sky with amazing accuracy and use those observations in their designs. Another astonishing fact is that the base of the Great Pyramid is almost completely flat. Across an area bigger than 3 football fields, the foundation is level to within just 2 centimeters. Experts think they may have used water to help with this. By digging shallow trenches and filling them with water, they could check where the surface was higher or lower and adjust it until everything was perfectly level. This shows how much thought and planning went into every step of construction. The Egyptians also understood how to use water as a tool in many different ways. Even though we don't have direct proof of all their methods, evidence from archaeology and historical writings points to some fascinating possibilities. For example, they may have taken advantage of the Nile River's yearly flooding. By building small canals from the river to their construction sites, they could float large stone blocks on wooden barges. This would have been much easier than dragging the stones over land. Water might also have played a role in their lifting systems. They could have used water-filled containers as counterweights. As workers added water to the containers, they became heavier and helped lift stones more gently and with greater control. Removing water would have the opposite effect, allowing them to lower stones just as carefully. There's even a theory that they used water to soften the ground. By flooding the construction area and then draining it, they could make the soil easier to shape, making it simpler to lay flat foundations and dig trenches. When combined with their impressive skills in geometry and measurement, this technique would have made their building projects even more precise. Another interesting theory is that the Egyptians may have made their own version of concrete, instead of using only carved stone blocks. Some researchers believe that they mixed crushed limestone with water and other materials to create a kind of stone paste. They could then pour this mixture into wooden moulds to form blocks right at the construction site. Supporters of this idea point to unusual features found in some pyramid stones, like air bubbles or layers that look poured rather than carved. If true, this method would have made construction faster and more accurate, and it would have solved the enormous problem of transporting giant stones over long distances. However, this theory is still debated. Many Egyptologists argue that the traditional method of cutting, dragging, and stacking stones is more likely, based on tool marks found on the blocks. Still, the very fact that such a theory exists shows how imaginative and resourceful the Egyptians must have been. Whether or not they used concrete, their achievements remain a powerful example of human ingenuity. And there's more. Some experts believe the Egyptians may have had a deep understanding of acoustics, or how sound behaves. In the wide, echoing halls of temples and pyramids, they may have used sound waves to guide their work. For instance, by striking a stone or playing a specific tone, they might have listened for echoes or vibrations to check if the structure was aligned properly. A clear and consistent echo could tell them the angles and surfaces were correct. There's even speculation that sound helped them move stones. Some researchers suggest that rhythmic chanting, drumming, or synchronized clapping might have helped reduce friction, or even influenced the sand underneath the sleds carrying the blocks. This idea is still very speculative, but it shows how sound might have been more than just music. It could have been a tool. Sound may also have helped workers communicate across large construction sites. With hundreds or even thousands of labourers working at once, clear instructions would have been difficult to hear. But with an understanding of how sound travels, they could have used specific tones, rhythms, or calls to send messages quickly and efficiently. Over the years, archaeologists and engineers have carried out many fascinating experiments to try and uncover the secrets behind how the ancient pyramids were built. One especially interesting project took place on the Giza Plateau, where a team led by Mark Lehner and Zahi Hawass decided to build a small model pyramid using only the tools and techniques that would have been available to the ancient Egyptians thousands of years ago. During this experiment, they discovered something surprising. When limestone blocks were slightly wetted, they slid much more easily across the desert sand. This simple trick helped challenge the long-standing belief that moving these heavy stones was nearly impossible without modern equipment. Meanwhile, on the other side of the world in Mexico, a group of construction workers performed a similar experiment to understand how the ancient Mesoamerican civilizations might have transported massive stones. Using only ropes, wooden rollers, and clever use of leverage, a group of about 12 workers was able to move a huge stone block weighing several tons with surprising ease. This experiment showed that the Maya and other ancient builders didn't need wheels or large animals to move their materials. They just needed teamwork, simple tools, and smart planning. In France, architect Jean-Pierre Houdin proposed a bold new theory: that the Great Pyramid of Giza might have been built from the inside out using a hidden internal ramp. To investigate this, researchers turned to modern technology. They used thermal imaging cameras and computer models to scan the interior of the pyramid. What they found supported Houdin's idea, showing possible internal structures that could have helped workers move the stones upward from within. This is a powerful example of how today's advanced tools, like computers and infrared technology, can help us solve mysteries that are over 4,500 years old. These kinds of experiments don't just show us how clever ancient builders were, they also make us rethink what we thought we knew about early engineering. By actually recreating the old techniques, modern researchers are discovering that ancient people were far more capable and inventive than we've often given them credit for. In Egypt, archaeologists have managed to cut and move massive limestone blocks using nothing but ancient tools. They showed that copper chisels, when regularly heated, reshaped, and cooled, can cut through limestone surprisingly well. To transport the stones, they used wooden sledges and rolled them over paths that were either slicked with water or lined with logs. These experiments proved that teams of workers could move stones weighing as much as 70 tons without machines. Similar trials have been carried out in England at the famous site of Stonehenge. Researchers there used wooden sledges, levers, and rollers to move giant sarsen stones, some of which weigh up to 40 tons. Even over long distances, the stones could be moved with careful planning and a strong, organized group of people. These results show that ancient societies truly did have the ability to complete monumental projects using nothing but simple tools and hard work. Down in South America, researchers have tried to replicate how the Inca created their famously precise stone walls. They discovered that by using bronze chisels, hammerstones, and gritty sand as an abrasive, they could cut and fit large blocks of andesite stone with astonishing accuracy, so tightly that not even a sheet of paper could fit between them. These efforts show just how skilled, patient, and detail-oriented Inca stonemasons really were. Building small versions of pyramids has also helped us better understand just how much thought went into their construction. One major lesson is that even a tiny mistake in leveling the base can cause big problems as the pyramid rises higher. This means the ancient Egyptian builders had to work with incredible precision, even without modern measuring tools. Some researchers have also recreated methods that might have been used to lift or move giant stones. Using sleds, levers, and carefully planned ramps, these models suggest that the builders could have completed these structures with a large workforce and well-organized teamwork. These modern recreations have given us a new level of respect for the planning skills of the ancient Egyptians. Managing huge teams of workers, making sure there were enough materials, and coordinating each stage of construction would have been a massive job. Even at a small scale, the amount of organization needed is impressive, proving that ancient Egyptian society was far more advanced than many assume. Today's computer simulations have taken the study of ancient building methods to a whole new level. These powerful tools allow scientists to test different ideas about how ancient monuments were built, without needing to lift a single stone. In Egypt, simulations have been used to test how different types of ramps or tools might have helped workers move the huge limestone blocks. One important finding is that wetting the sand can greatly reduce friction, making it easier to slide heavy stones. This lines up with what ancient Egyptians were capable of at the time. In Central America, computer models have helped researchers figure out how the Maya built their enormous temples, often on unstable, swampy ground. These simulations showed that the Maya used smart techniques to build strong foundations that prevented their temples from sinking or collapsing. The models also offered new insights into how they moved and positioned large stones using only simple tools and human labor. But computer models don't just help with single buildings, they also help us rebuild entire ancient cities. By combining information about terrain, available materials, and known construction practices, these digital reconstructions give us a detailed picture of life in ancient cities like those in the Indus Valley or ancient Rome. They don't just show how buildings went up, they reveal how people lived, how cities were organized, and how resources were managed. The field of experimental archaeology continues to play a huge role in helping us understand the mysteries of pyramid building. By trying out ancient techniques in real life, researchers have gained valuable knowledge about how the Egyptians may have worked. In one experiment, teams moved and placed massive limestone blocks using wooden rollers and sledges. They proved that even a small group of workers could move heavy stones efficiently. This kind of evidence helps debunk popular theories that say ancient people needed help from aliens or lost advanced civilizations. Other tests focused on cutting and shaping stone. With copper chisels, bronze saws, and quartz sand, archaeologists managed to create the same kinds of marks seen on stones from the Great Pyramid. These findings show that ancient tools, though simple, were incredibly effective in the hands of skilled workers. Ramp building has also been explored. Researchers have built scale models and even life-size ramps to test ancient designs, described in old writings and modern theories. These trials helped identify which ramp systems would have worked best for lifting blocks up the pyramid. Studying ancient quarry sites has also provided a wealth of information. Archaeologists have visited the old quarries near the Giza pyramids and found clear evidence of how the stones were extracted. Tool marks on quarry walls, leftover stone chips, and carved ramps have helped researchers reconstruct how the ancient builders worked. They used tools like copper chisels, bronze saws, and wooden wedges to split the limestone. By analysing the stones, scientists have also learned how the Egyptians chose specific types of rock for different parts of the pyramid. They even had the geological knowledge to select the right kind of stone for each purpose. This reveals just how organised and well-informed the builders were. In recent years, archaeologists and scientists have started using some of the most advanced tools of our time to uncover how ancient people managed to build their massive monuments. These modern technologies are helping us peek into the distant past without even touching the ancient stones. One powerful tool is called ground-penetrating radar. This amazing device lets scientists look beneath the Earth's surface without having to dig. It works like an X-ray for the ground, showing what lies hidden under layers of soil and sand. With it, entire ancient cities that have been buried for hundreds or even thousands of years can be mapped out. The radar has also helped researchers understand how ancient foundations were built and where hidden structures might still be waiting to be found. Another game-changing technology is laser scanning, which is often combined with three-dimensional digital modeling. These tools let scientists create extremely detailed digital versions of ancient buildings. With the help of these virtual models, researchers can zoom in to see tiny tool marks left behind by ancient workers, measure angles and distances with great accuracy, and even run computer simulations to figure out how the structures were put together. It's like rebuilding ancient wonders piece by piece, without ever lifting a real stone. Then there's spectroscopic analysis, a fancy term for a method that breaks down the light reflected by a material to see what it's made of. This technique has helped experts learn exactly where ancient stones came from, which offers clues about trade routes and resource management. It can even reveal what kinds of pigments were used in painted decorations, giving us a glimpse into the artistic styles and colour choices of ancient cultures. Artificial intelligence is also stepping into the world of archaeology. Smart computers are now being used to scan and study enormous amounts of data, including thousands of artifacts, ruins, and building features. These machines can spot patterns and connections that human eyes might miss, such as similarities between buildings in different regions or time periods. In doing so, AI may help us rediscover lost building techniques that were once common knowledge, but have long since been forgotten. One of the most hands-on and exciting fields in archaeology today is called experimental archaeology. In this area, researchers try to recreate the tools and methods that ancient people once used to see how well they worked. For example, by crafting copper chisels, bronze saws, and wooden sleds, just like those the ancient Egyptians might have used, scientists have been able to test out old construction techniques in real life. One truly surprising discovery from these experiments is how effective wet sand can be when dragging heavy stones. Researchers found that by pouring water in front of a wooden sled carrying a giant stone block, they could cut the effort needed to pull it in half. That means only half as many workers were needed, just by using water to reduce friction. This clever trick might have been a key part of how the ancient Egyptians moved their massive limestone blocks across the desert. Recreating ancient tools has also helped modern experts understand just how precise Egyptian builders were. Using simple tools like plumb bobs for checking vertical lines, wooden set squares for right angles, and water levels to make things flat, the Egyptians were able to achieve nearly perfect 90-degree angles and flat surfaces across enormous areas. These basic tools, used with great skill, show that the Egyptians had a deep understanding of geometry and engineering. Through these experiments, researchers have also learned more about how the work was organized. Building a pyramid was not just about muscle and stone, it required planning, teamwork, and clever management. Evidence suggests that workers were divided into expert teams, with each group focusing on a specific task. This division of labour shows that the Egyptians had sophisticated systems in place, even over 4,000 years ago. Some of the greatest clues about pyramid construction have come from unfinished pyramids scattered across Egypt. These incomplete structures are like time capsules. They show us different stages of the building process frozen in time. By studying them, archaeologists can see how the pyramids were built step by step. One important technique revealed by these unfinished pyramids is the use of accretion layers. Instead of building from the bottom straight up, the Egyptians built from the inside out, placing each layer of stone at an inward angle. This made the structure more stable while it was still under construction, and allowed work to continue smoothly even as outer layers were added. Unfinished pyramids have also revealed traces of ramps, levers, and other clever tools used to move and position giant blocks. These clues have helped researchers recreate the mechanical strategies the Egyptians may have used to handle such massive stones. It's like piecing together a gigantic puzzle from thousands of years ago. In addition to construction methods, These sites have shown how the ancient Egyptians managed their workforce. The evidence points to a highly organised system where skilled labourers were divided into teams based on their specialties. Some shaped the stones, some transported them, and others placed them with great care. All of this was happening during the Old Kingdom period, more than 4,500 years ago. Modern engineering has taken our understanding of ancient construction to a whole new level. Today, computer simulations and digital models allow experts to test ancient building methods in a virtual space. By doing this, they can find out how ancient structures handled stress, pressure, and weight, helping to explain how some of them have stood strong for thousands of years. These digital tests have shown that ancient builders had an incredible, almost instinctive understanding of engineering, even though they didn't use complex mathematics as we do today. They knew how to build things that lasted, and many of their techniques still impress modern engineers. Scientists studying ancient building materials have made some eye-opening discoveries as well. For example, the ancient Romans used a special kind of concrete that has turned out to be stronger and longer lasting than most concrete used today. Researchers are now trying to copy those ancient recipes to create better materials for modern buildings. Engineers have also been exploring how ancient people managed to move stones weighing tens or even hundreds of tons. By applying geotechnical engineering, the science of how soil and rock behave, they have developed new ideas about how ramps, levers, and wooden sledges may have been used. Practical tests have shown that with enough planning and teamwork, these simple tools were surprisingly powerful. Altogether, this combination of modern technology, hands-on experiments, and a fresh look at ancient remains is helping us uncover the true genius of our ancestors. The more we learn, the more we realize that ancient civilizations, especially the Egyptians, were far more advanced than we ever imagined. The building of the Great Pyramids in Egypt and the mysterious circle of stones at Stonehenge in England are two of the most amazing accomplishments from the ancient world. Even though they were built in different places and under very different circumstances, both of these massive projects show just how clever and determined ancient people were, even without modern tools or machines. The Great Pyramids were constructed about 4,500 years ago in the deserts of ancient Egypt. These enormous triangular monuments were made by carefully cutting and moving huge blocks of limestone, each weighing several tons. The blocks were transported from quarries, dragged across the sand, and stacked with remarkable precision to create a perfectly shaped pyramid that has lasted for thousands of years. This task required careful planning, incredible teamwork, and an understanding of math and astronomy that was far ahead of its time. Stonehenge, on the other hand, began to take shape around 4,500 years ago and continued to be built and added to until about 3,500 years ago. Instead of a pyramid, Stonehenge is a circular arrangement of giant stones placed upright in the countryside of southern England. Some of these stones, known as bluestones, were brought from quarries located more than 150 miles away, a stunning accomplishment for people who had no wheels or engines. Moving such heavy stones over such long distances must have taken enormous effort, creativity, and cooperation. Both the Great Pyramids and Stonehenge show that ancient people had a deep understanding of the stars and the movements of the sun and moon. The Great Pyramids were built with their sides aligned almost perfectly to the north, south, east, and west. Stonehenge, meanwhile, was carefully arranged to line up with the rising and setting of the sun during important times of the year, like the summer and winter solstices. These alignments were not accidents. They show that ancient builders carefully studied the sky and designed their monuments to match important celestial events. The tools used in each project were very different, depending on the materials available and the type of work needed. In Egypt, the builders likely used copper chisels to cut the limestone, along with bronze saws, wooden sleds, rollers, and long ramps to move the blocks into place. At Stonehenge, the builders worked mostly with very hard stones, so they probably used hammerstones and chisels made from tougher rock. They also used wooden sledges, ropes, and logs as rollers to haul the stones across the land. Interestingly, the Great Pyramids of Egypt also share many similarities with the pyramid-like structures built in South America, despite the fact that these civilizations were separated by entire oceans and thousands of years. In both Egypt and places like Peru and Mexico, ancient people built large stone monuments in pyramid shapes that were used for religious ceremonies or as tombs. These buildings were often aligned with the stars or important solar events, just like the pyramids and Stonehenge. Another amazing similarity is the way the stones were cut and fitted together. Both Egyptian and South American builders managed to shape massive blocks of stone so perfectly that they fit tightly together without the use of cement or mortar. Even today, modern engineers are still puzzled by how such a high level of precision was achieved using only simple tools. The scale of these projects also tells us something important. Both the Egyptians and the South Americans had highly organized societies with strong leadership and skilled workers. Building such huge monuments would have required planning, resource management, and the ability to organize and direct large groups of laborers. These ancient civilizations clearly had complex systems in place to support such enormous efforts. The Great Pyramid of Khufu, the largest of the pyramids at Giza, is especially awe-inspiring. Built around 4,500 years ago, it originally stood at a height of 146 meters, making it the tallest structure in the world for more than 3,800 years. The base of the pyramid measures 430 meters on each side and is almost perfectly level, with less than a few centimeters of difference across the entire structure. That kind of accuracy is hard to match even with modern building equipment. To construct it, the Egyptians used an estimated 2.3 million stone blocks, some weighing as much as 70 tons. Each block was placed with such care that the sides of the pyramid are aligned with true north with an error of less than 1/10 of 1 degree. This extraordinary level of precision is unmatched by any other ancient monument, and it continues to amaze experts today. Even when compared to other famous wonders of the ancient world, like the Hanging Gardens of Babylon or the statue of Zeus at Olympia, the Great Pyramids stand out. While many other ancient structures have been lost to time, the pyramids still stand tall, having survived thousands of years of wind, sand, and weather. This is a powerful example of how well the ancient Egyptians understood materials and construction techniques. Surprisingly, the Great Pyramids also have things in common with structures found in Asia. Many ancient Asian temples, ziggurats, and pyramid-shaped buildings also show incredibly precise stonework and a deep knowledge of astronomy. Just like in Egypt, many of these buildings were lined up with stars, the sun, or the moon, showing that ancient people in different parts of the world were paying close attention to the sky. Earlier pyramids in Egypt were built with a stepped design, which closely resembles the styles used in ancient Asian buildings such as the ziggurats of Mesopotamia or the temple platforms found in places like Cambodia and Indonesia. Both Egyptian and Asian builders also created hidden passageways and rooms inside their monuments. These inner chambers were used for burials, rituals, or spiritual purposes, proving that the builders didn't just think about the outside. They also gave great importance to what went on inside their sacred structures. When we look at the engineering achievements of ancient Egypt alongside those of ancient Rome, we see two very different but equally impressive traditions. The Egyptians focused on building giant structures like the pyramids using massive stones and precise alignment with the stars. The Romans, who flourished more than 2,000 years after the pyramids were built, developed new construction techniques like concrete, arches, and domes. These innovations allowed them to build vast cities, strong bridges, aqueducts to carry water, and public buildings that still stand today, such as the Pantheon. Roman buildings were designed to be practical as well as beautiful. Their roads, many of which still exist, were carefully planned and built to last. The Romans used repeating designs and standardized materials so they could build quickly across their vast empire. In contrast, the Egyptians focused their efforts on creating monumental tombs that would last forever, using enormous resources to build a few truly colossal structures. Both civilizations showed great skill in solving the problems of their time. The Egyptians mastered how to move and stack giant stones with incredible accuracy, while the Romans figured out how to build large cities with running water, public spaces, and efficient transportation. Today, the legacy of both still surrounds us, in the form of awe-inspiring monuments, ancient cities, and the deep curiosity they continue to inspire in everyone who studies the past. Across the world, from the sandy deserts of Egypt to the grassy plains of North America, ancient monuments continue to reveal surprising similarities. Even though the people who built these great structures lived thousands of miles apart and were separated by thousands of years, they often came up with remarkably similar ideas. One of the most fascinating comparisons is between the Great Pyramids of Egypt and the massive earthen mounds built by Native American civilizations, such as the ones at Cahokia in present-day Illinois. The Egyptian pyramids were built around 4,500 years ago, and they remain some of the most famous structures in human history. Meanwhile, the city of Cahokia thrived over 1,000 years ago, and was the largest and most sophisticated settlement north of Mexico at the time. At the heart of Cahokia stands Monk's Mound, a stepped pyramid of earth that rises nearly 100 feet high. Like the Great Pyramids of Giza, Monk's Mound was built with careful planning and served as a powerful symbol of religion, politics, and culture for the society that built it. What is truly striking is how both the Egyptian pyramids and the North American mounds were used as sacred centres, places that connected people to their gods, leaders, and ancestors. These monuments were not just buildings, they were spiritual landmarks. Inside many of them, archaeologists have discovered burial chambers and ceremonial artifacts, which shows that both cultures used these sites for rituals connected to death and the afterlife. This shared purpose hints at a deep, universal human desire to reach for the heavens, to honour the dead, and to create something that would last for all time. Another amazing similarity is the incredible precision both cultures achieved in their construction. The Great Pyramids of Egypt are aligned almost perfectly with the four cardinal directions: north, south, east, and west. In fact, their deviation from true north is less than 1/10 of a degree, a level of accuracy that still astonishes modern scientists. Likewise, many North American mounds are also aligned with astronomical events, such as the positions of the sun and moon during solstices and equinoxes. These alignments suggest that both the Egyptians and Native Americans were skilled astronomers who understood how to track the movements of the stars and used this knowledge when building their sacred monuments. The Egyptians, however, were not alone in aligning their structures with the heavens. All around the world, ancient civilizations were doing the same thing in their own unique ways. In England, for instance, the mysterious stone circle known as Stonehenge is perfectly aligned with the rising sun on the summer solstice. On that special day, sunlight passes directly through the heart of the monument, casting a golden glow that marks the longest day of the year. Far to the west, in the jungles of Central America, the ancient Maya built the Pyramid of El Castillo in the city of Chichen Itza. During the spring and autumn equinoxes, a shadow appears on the side of the pyramid that looks like a serpent slithering down the staircase. This magical effect was no accident. It was carefully designed by master builders and astronomers who understood the cycles of the sun. In South America, the Inca also looked to the skies. In their mountain city of Machu Picchu, the famous Intihuatana stone, sometimes called the hitching post of the sun, was carved and placed to track the equinoxes. Meanwhile, in what is now Mexico City, the mighty Aztecs built the Templo Mayor in alignment with the rising of the Pleiades star cluster, a key event in their calendar and religious beliefs. But when it comes to pure accuracy, the Great Pyramids still stand above the rest. Their near-perfect alignment and enormous scale continue to puzzle and impress engineers, architects, and historians. How did people so long ago, without modern tools, manage to achieve such a feat? This mystery continues to inspire research and imagination to this day. Even structures built much earlier than the pyramids, such as Göbekli Tepe in modern-day Turkey, show surprising similarities. This site, which was built more than 11,000 years ago, is considered the world's oldest known temple. Like the pyramids, Göbekli Tepe features massive stone pillars, some weighing as much as 20 tons. These T-shaped stones were arranged in circular patterns, and they too show signs of alignment with the stars. Remarkably, both at Göbekli Tepe and in Egypt, the builders shaped and placed huge stones with such skill that the blocks fit together perfectly without the use of mortar. This kind of craftsmanship required deep knowledge of stone cutting and engineering, and it shows that even ancient societies had the brain power and creativity to pull off complex projects. In both places, the builders planned their work with great care. Some archaeologists believe that Göbekli Tepe's circular enclosures were designed to mark celestial events, much like the pyramid's alignments with the stars. These common practices suggest that looking to the skies was not unique to one culture, but rather a shared human instinct to find meaning in the stars and reflect that meaning in the structures they built. While the Great Pyramids were mostly made from limestone and granite quarried from nearby locations, other ancient cultures chose different building materials depending on what was available to them. In ancient Mesopotamia, for example, builders used sun-dried mud bricks to create towering ziggurats. These stepped temples were often covered with fired bricks on the outside to protect them from the elements. Though the materials were different, the design philosophy was similar: create something tall, powerful, and lasting that connected the heavens and the earth. In Central America, the Maya and Aztecs built their own pyramids using cut limestone and rubble fill. These were often brightly painted and decorated with carvings and images of gods, animals, and celestial events. Unlike the smooth faces of the Egyptian pyramids, these step structures were more vibrant and expressive, adding a layer of art to their engineering. Over in Asia, the Great Wall of China stretched across mountains and valleys, using whatever materials were locally available, sometimes stone, sometimes brick, and sometimes just tightly packed earth. This adaptability shows how ancient builders were creative and resourceful, turning the land itself into their toolbox. Beyond materials and methods, ancient cultures also shared ideas and symbols that appeared again and again, even across continents. One such symbol is the serpent. In ancient Egypt, the snake was often associated with protection and power. Across the ocean, the Maya and Aztecs also used the image of the serpent, sometimes winged, sometimes feathered, to represent gods of knowledge and rebirth. Another fascinating link is the use of geometric patterns and sacred numbers. The Egyptians built their pyramids using proportions that reflect the golden ratio, a mathematical pattern that shows up in nature, such as in the spirals of shells or the shapes of galaxies. Structures like the Parthenon in Greece and Hindu temples in India also seem to follow similar mathematical principles. This points to a shared human appreciation for harmony, beauty, and balance. All of these connections between pyramids, mounds, stone circles, temples, and walls suggest that ancient people all over the world were driven by similar goals: to understand the cosmos, to honor their gods, to mark the passage of time, and to leave behind something eternal. Though they spoke different languages and lived in different places, they looked up at the same stars and were inspired to build wonders that still speak to us today. Recently, researchers have discovered some mysterious and fascinating energy-related phenomena around these ancient monuments. These findings have led to ongoing discussions and debates among experts, while also inspiring wonder in countless others. One of the most curious discoveries involves strange electromagnetic effects inside the pyramid. Scientists have observed that the Great Pyramid seems to gather and concentrate electromagnetic energy, especially radio waves, in its inner chambers. It's almost as if the pyramid is acting like a giant antenna, pulling in invisible energy and focusing it into specific rooms. This is especially noticeable in the central parts of the pyramid, where the energy seems to be strongest. Another strange phenomenon involves the area right above the top of the pyramid, known as the apex. Some researchers claim to have detected what they describe as an energy vortex, a kind of swirling field of energy that rises upward from the very peak. They say this mysterious energy becomes even stronger during certain times of the day, or during special alignments of the sun, stars, or planets. Although not yet fully understood, this phenomenon continues to puzzle scientists and excite alternative researchers. There have also been reports of static electricity gathering around the pyramid, especially near its top. Visitors and investigators have sometimes felt a tingling sensation on their skin, like a mild electric shock, or seen tiny sparks when they touch the stone under certain weather conditions. While these reports are not yet fully confirmed, they raise intriguing questions about how the pyramid might interact with the environment. Scientists have also explored the idea that the shape and design of pyramids may affect the world around them in subtle ways. Some experiments have shown that pyramid-shaped objects, even small ones made for research, can have an impact on plants and organic materials. In some studies, seeds placed inside miniature pyramid models sprouted faster and grew healthier than seeds planted under normal conditions. Some believe this is because the pyramid shape helps gather energy that supports plant growth. Even more amazing are findings related to preserving food inside pyramid-shaped structures. Researchers have noticed that fruits and vegetables placed inside these models tend to dry out instead of rotting, keeping their shape for much longer than usual. Scientists suggest that the pyramid might create a kind of microclimate, a small zone with less moisture, where bacteria and fungi struggle to survive, thus slowing down the natural decay process. Still, not everyone agrees on why or how these effects happen. While many experiments show interesting results, more studies are needed to understand the exact science behind them. Scientists want to know whether these effects can be reliably repeated, and whether pyramid shapes truly have unique energy-related properties. The acoustics, or sound behavior, inside the pyramids are also deeply fascinating. Inside the king's chamber of the Great Pyramid, for example, sound behaves in strange and powerful ways. Researchers have found that this room has very specific resonant frequencies, especially around 20 Hz, which is just below what human ears can hear. This deep sound, though silent to our ears, can still be felt by the body, giving people a sensation of vibration, or even awe when they are inside. Another odd acoustic effect is the way the pyramid can focus and carry sound. In some chambers and hallways, even the softest whisper can travel surprisingly far and be heard clearly. Some scientists believe this could have been used intentionally by the ancient Egyptians during rituals or ceremonies. Others think it may have simply been a fascinating result of the pyramid's clever construction. Experiments on the outer surface of the pyramid also show that it can reflect and scatter sound waves in unusual ways. The exact patterns of how the pyramid handles sound are still not completely understood, and many researchers believe this might be another example of advanced ancient knowledge, perhaps shared by other ancient cultures across the world, who also built pyramids and mysterious stone structures. In addition to all this, the pyramids are constantly being bombarded by cosmic radiation, high-energy particles that travel through space and reach Earth from exploding stars, distant galaxies, and other powerful cosmic events. These cosmic rays interact with everything on Earth, including ancient structures like the pyramids. Because the pyramids are made of huge blocks of stone, they can block, scatter, and absorb some of this radiation. Scientists have taken advantage of this by using a special method called muon tomography. This technique uses tiny particles called muons, which are created when cosmic rays hit Earth's atmosphere. These muons can pass through solid rock, and by measuring how many get through the pyramid, scientists can create something like an X-ray image of its interior. Using this method, they have already found hidden chambers and voids inside the Great Pyramid, without damaging a single stone. These discoveries are not just helping us learn more about the pyramids themselves, they're also helping scientists develop new technologies for imaging and scanning other ancient structures, or even modern buildings. The idea that something built over 4,500 years ago is now helping us understand both the ancient past and the laws of particle physics is truly astonishing. In recent years, scientists have also noticed other strange energy-related behaviors around the pyramids. At the very top of the Great Pyramid, researchers have measured concentrated electromagnetic energy, not just inside the chambers, but also directly beneath the base. Some believe the shape and materials of the pyramid may naturally gather and focus energy in unique ways. Some bold studies even suggest that these energy fields might be able to slow the breakdown of materials or even influence living organisms. Though this remains controversial, the idea continues to attract attention. Thermal cameras have also picked up hotspots on the pyramid's surface, patches of higher heat that cannot be easily explained. These mysterious warm areas may be caused by internal structures hidden deep within the pyramid, or perhaps by the unique properties of the limestone used in construction. In addition, ultrasound scans have picked up strange vibrations and echo patterns inside the pyramid's inner rooms. These may point to unknown qualities of the design that cause the structure to focus or direct energy in specific ways. Still, like many of the other discoveries, these ideas need more careful study and peer-reviewed research before any solid conclusions can be drawn. However, there's one more surprising connection between the pyramids and nature: the way these ancient structures seem to affect underground water. Because the pyramids are so heavy, they press down on the ground beneath them, squeezing the earth and rock below. This pressure can change the way underground water moves through the area. In some cases, the foundations of the pyramids, which stretch deep below the surface, may block or redirect natural water paths. This can cause changes in local vegetation, soil conditions, and even affect how the pyramids themselves hold up over time. The relationship between these ancient structures and the earth beneath them shows how complex and unexpected the effects of architecture can be, even thousands of years later. The Giza Plateau in Egypt, where the world-famous pyramids stand, has long fascinated scientists and tourists alike. But in recent years, researchers have started to notice some truly unusual weather and environmental patterns happening right around these ancient structures. These strange effects suggest that the pyramids may actually influence the air, temperature, and even electricity in their surroundings. One of the most curious discoveries involves the appearance of tiny swirling whirlwinds, known as dust devils, near the base of the Great Pyramid of Khufu. These little tornado-like spirals of sand and air seem to form more often around the pyramid than in other parts of the desert. Scientists believe the pyramid's special shape, with its flat base and sharp peak, might be creating a kind of airflow that causes these spinning columns to appear. The smooth, sloping sides and the alignment of the pyramid with the sun and wind may help shape the unique weather just around it. Another surprising phenomenon is how the temperature changes very quickly near the pyramids. Researchers have recorded temperature differences of as much as 5 degrees Celsius, that's 9 degrees Fahrenheit, between the base of the pyramid and the desert nearby. This happens because the massive stone blocks of the pyramid heat up and cool down at a different rate than the sand and soil around them. These stones soak up heat during the day and slowly release it after the sun sets, creating little pockets of warmer or cooler air that don't follow the usual desert patterns. Even more fascinating is the electrical activity that seems to increase in the air around the Giza Plateau, especially during the hot and dry Khamsin winds. These winds blow through the region in the spring, often bringing dust and very low humidity. During this time, scientists have noticed stronger electric fields near the pyramids. Some experts think the limestone blocks, rich in certain minerals, combined with the pyramid's shape and the weather, might help build up static electricity or even create localized electric fields. But this idea is still being studied, and much more research is needed to truly understand what's going on. While scientists are exploring these new discoveries, it's worth remembering that the pyramids themselves have already amazed the world for thousands of years. The Great Pyramid of Khufu, for example, was built more than 4,500 years ago and still stands tall today. While many other buildings from ancient times have crumbled or disappeared, the pyramids remain massive, silent, and strong. Their incredible strength comes from several clever choices the ancient Egyptians made. First, they built the pyramids from limestone, a natural rock made mostly of calcium carbonate. Over time, when this stone is exposed to air and moisture, it goes through a process called case hardening. Its surface becomes harder and more protective, like a natural armour. This means the longer the stone sits out in the elements, the tougher it becomes on the outside. Second, the design of the pyramids helps them last. Their wide base and gradually narrowing sides mean that the weight of the stone is spread out evenly. This keeps pressure from building up in any one place, reducing the chance of cracking or collapse. Plus, the sloped sides help water run off quickly when it rains, which prevents erosion and water damage. The dry desert climate has also played a huge role. Egypt's weather is mostly hot and dry, with very little rain and almost no freezing temperatures. In other parts of the world, freezing and thawing can crack rocks over time, but in Egypt, the pyramids are spared this kind of damage. Thanks to this perfect mix of smart engineering, strong materials, and desert weather, the pyramids have stayed remarkably well preserved for over 4 millennia. But the mystery doesn't stop there. For centuries, people have reported seeing strange lights, ghostly mists, and even unexplained figures around the pyramids, especially at night. These lights are often described as glowing orbs that float in the air or dart around in odd patterns. Some have even been caught on camera, but no one can say for sure what causes them. They might be reflections, illusions, or perhaps something else entirely. Other visitors have noticed thin fogs or misty clouds that seem to appear out of nowhere near the base of the pyramids, even on clear, dry days. These mists sometimes move in eerie ways or form unusual shapes, which only adds to the sense of wonder and mystery. And at night, a few people have claimed to see shadowy figures walking among the stones. Skeptics often say it's just tricks of light and shadow, but others believe these could be connected to the ancient Egyptians' deep spiritual beliefs, perhaps even echoes of souls from the past. In addition, scientists and visitors alike have seen optical illusions or mirages near the pyramids, where distant shapes appear to be structures or landscapes that don't actually exist. These visual tricks have led some to believe there may be hidden chambers or secret parts of the pyramids that haven't yet been discovered. Perhaps one of the most mind-bending scientific findings comes from the field of physics. Using highly advanced tools like atomic clocks, scientists have discovered that time itself flows just a tiny bit differently at the top of a pyramid than it does at the base. This effect is called gravitational time dilation, and it's something predicted by Albert Einstein's theory of general relativity. Here's how it works. Because the pyramid is so massive, its gravity slightly affects the flow of time. The difference is incredibly small, just a few fractions of a second over thousands of years, but it is real and measurable. What's even more interesting is that the shape of the pyramid might make this effect slightly stronger by focusing gravitational energy. While this idea is still being explored, it shows how the ancient pyramids are not just archaeological wonders, they're also windows into the deepest laws of the universe. All across the ancient world, long before the age of airplanes or the internet, people on different continents were building structures that looked surprisingly alike. Pyramids. These tall, triangular monuments rose from the earth in places separated by thousands of miles and thousands of years. Yet somehow, they shared strikingly similar shapes, purposes, and even building techniques. It's one of the most fascinating examples of how human creativity and imagination can take root in many different places, completely independently. In Africa, the most well-known pyramids are, of course, those of ancient Egypt. These incredible stone giants were built more than 4,500 years ago as tombs for powerful pharaohs, kings who were believed to become gods in the afterlife. The most famous of these is the Great Pyramid of Giza, a structure so large and precise that it still amazes engineers today. But pyramid building in Africa didn't end with Egypt. Far to the south, in what is now modern-day Sudan, the ancient kingdom of Kush continued this tradition. The Kushites built their own pyramids, many of which were smaller and steeper than those in Egypt, but just as meaningful. They built hundreds of them over time, long after Egypt had stopped building its own. Now imagine crossing the Atlantic Ocean to the ancient Americas. Here too, pyramid structures rose from the jungles and plains. In Mesoamerica, an area that includes present-day Mexico, Guatemala and Belize, the Maya and Aztecs built step pyramids at the heart of their great cities. These weren't tombs like those in Egypt, but temples where priests performed sacred rituals and offered sacrifices to the gods. Some were painted in bright colours and decorated with carvings of serpents, jaguars, and celestial symbols. Farther south, in present-day Peru, the Moche culture built massive pyramid-shaped temples out of adobe bricks. These structures, called huacas, were used for ceremonies and also served as places of worship. Even in what is now the United States, the Mississippian peoples of North America raised enormous earthen mounds. Some of these, like Monk's Mound in Cahokia, Illinois, had pyramid-like shapes and were used for religious and political purposes. Asia, too, had its own pyramid traditions. In China, over 2,000 years ago, the first emperor Qin Shi Huang was buried beneath a vast earthen pyramid, surrounded by the famous terracotta army. And in Indonesia, the enormous Buddhist temple of Borobudur was built over 1,200 years ago. This stepped pyramid, made of stone, rises like a mountain and is covered in carvings that tell sacred stories. What's so amazing is that all these pyramid structures, from Egypt to Mexico, from Peru to China, share a similar shape, wide at the bottom and narrowing toward the top. This design wasn't just chosen because it looked beautiful. It was also incredibly strong. A pyramid shape spreads weight evenly and can stand tall without collapsing, which made it the perfect form for ancient builders working without cranes or modern machinery. Another thing these pyramids had in common was their connection to the divine. In Egypt, the pyramids were resting places for pharaohs, built to help them journey into the afterlife. In Mesoamerica, pyramids were sacred spaces where priests communicated with the gods. In all these places, the pyramids symbolized a bridge between the earth and the heavens. Even the ways these structures were built show surprising similarities. Many ancient builders used a method of stacking stone or brick in layers, often starting with a stepped design. Later, they might smooth out the sides with carefully cut stones. The fine stonework seen in the Egyptian pyramids, where massive blocks were fitted so closely that not even a razor blade can slip between them, is echoed by the stone-cutting skills of the Inca in South America, who built temples and fortresses with the same kind of precision. The step pyramids of Mesoamerica and the smooth-sided pyramids of Egypt represent different styles, but both reflect the deep cultural and spiritual beliefs of their makers. In cities like Teotihuacan and Chichen Itza, the Mesoamerican pyramids had grand staircases climbing up to temples at the top, used for rituals and sacrifices. These structures were often rebuilt and enlarged over generations, growing taller as new layers were added by each new ruler. In contrast, Egypt's pyramid style evolved from earlier stepped designs, like the step pyramid of Djoser, into the sleek, smooth-sided pyramids we recognize today. The Great Pyramid of Giza, with its perfectly angled sides and polished limestone casing, was built as a final resting place for a pharaoh, and filled with treasures for his life after death. While the exact roles of these pyramids differed, some were tombs, others were temples, they all served as awe-inspiring monuments to human faith, power, and skill. And they all reached upward, as if trying to touch the sky. But perhaps the most mysterious part of all this is how similar the pyramids are despite the vast distances between the cultures that built them. Some pyramids are aligned with incredible precision to the stars. The Great Pyramid of Giza, for example, points almost exactly to true north. In Mexico, the pyramids of Teotihuacan line up with the Pleiades star cluster. This kind of celestial alignment suggests that ancient builders were not only skilled architects, but also careful observers of the sky. There's even evidence that these ancient cultures used advanced mathematical concepts. Both the Egyptian and Mesoamerican pyramids seem to include the golden ratio in their designs, a number often found in nature that many believe creates beauty and harmony in art and architecture. All of these shared features have led some researchers to wonder whether the people who built these pyramids could have been connected in some way. Did knowledge somehow travel across the world long before modern ships or planes? Or did different cultures come up with the same ideas on their own, inspired by similar needs and observations of nature? Most experts believe that these similarities are examples of independent invention. In other words, humans around the world face similar challenges, how to build large, stable, awe-inspiring monuments, and came up with similar solutions. But the mystery continues to spark curiosity and debate. In northern Africa, the ancient Egyptians built the Great Pyramid of Giza more than 4,500 years ago. What makes this pyramid so amazing is how perfectly it is aligned with the four cardinal directions: north, south, east, and west. The sides of the pyramid line up so exactly with these directions that some experts believe it was used as a kind of giant calendar. When the sun moved across the sky during solstices and equinoxes, the pyramid's shadows would shift in ways that helped track the seasons. Meanwhile, on the other side of the world in Mesoamerica, the Maya built their own pyramids with equally impressive knowledge of the stars. One of the most famous is the Temple of Kukulkan at Chichen Itza, which was designed so that during the spring and autumn equinoxes, the setting sun casts a shadow that looks like a giant snake slithering down the pyramid steps. This magical sight, known as the Descent of Kukulkan, shows just how well the Mayans understood the movement of the sun and how they brought this knowledge into their sacred buildings. Further south in Peru, the ancient city of Machu Picchu, built by the Inca, contains structures that are aligned with the sunrise during the June solstice. And over in Southeast Asia, the ancient temples of Angkor Wat in Cambodia line up perfectly with the spring equinox. Across continents and cultures, these examples reveal a deep and shared human desire to connect buildings on Earth with movements in the sky above. Today, scientists and researchers are still amazed by the incredible accuracy of these alignments. They raise fascinating questions about just how much the ancient people understood about astronomy and engineering. Many of these pyramids were more than just tombs or temples. They were also ancient observatories and calendars carved into stone, linking life on Earth with the vast rhythms of the universe. Across many civilizations, pyramids share similar building styles, even though the cultures were separated by thousands of miles and often by thousands of years. One feature that almost all pyramids have in common is their shape, a broad, wide base that narrows as it rises to a single point or flat top. This design is naturally strong and stable, helping the pyramid stay standing for thousands of years, even through earthquakes and harsh weather. Most pyramids were built with stone blocks that were carefully cut and placed with incredible precision. Builders often used stone from nearby areas and shaped each block so precisely that in many cases they didn't even need mortar. The sheer weight of the stones held everything together. In some pyramids, the blocks fit so tightly that even a knife blade can't be slipped between them. Another common feature is the use of secret inner chambers and narrow passageways. These hidden spaces were not randomly placed. They often had religious or ceremonial purposes and were sometimes aligned with stars or planets. Building rooms inside such heavy stone structures required careful planning and advanced knowledge of how to keep them from collapsing. Many pyramids were also built using a step design, with levels stacked one above the other like a giant staircase. In some places, the steps were left visible, while in others, they were covered with smooth layers to give the pyramid a sleek appearance. The step design made it easier for workers to carry heavy materials up the structure and gave the builders a stable platform as they built higher and higher. Pyramids had different purposes depending on the culture. In ancient Egypt, they were royal tombs made to protect the bodies and treasures of pharaohs. Egyptians believed these mighty buildings helped their kings travel safely to the afterlife and live forever among the gods. In Central America, the Maya and the Aztecs built pyramids that were more like religious centers than tombs. These pyramids often had temples at the top, where priests would perform important ceremonies. Some of these rituals included human sacrifices, which were believed to please the gods and keep the world in balance. Many Mesoamerican pyramids were also rebuilt multiple times, with new layers added on top of older ones, creating monuments that held generations of history. In the ancient land of Mesopotamia, people built pyramid-like structures called ziggurats. These were large platforms made of mud bricks, with temples at the top. People believed the gods lived in these temples, and building tall platforms brought them closer to the heavens. The Nubians of ancient Sudan, south of Egypt, also built pyramids, although theirs were smaller and had steeper sides. These too were royal tombs, showing how Egyptian influence had spread to nearby lands. In ancient China, some pyramids were used as tombs for emperors, often shaped like massive flat-topped mounds. Some may have even had an astronomical function. These wide-ranging examples show how different cultures adapted the pyramid shape to reflect their own beliefs, values, and traditions. The global trend of pyramid building has fascinated archaeologists for centuries. Many theories try to explain why so many ancient civilizations built these incredible structures. One well-known idea is that pyramids were built as tombs for powerful rulers, especially in Egypt. These giant buildings were meant to protect the king's body, hold his treasures, and help his soul reach the afterlife. Another theory is that building pyramids was a way for rulers to show off their power and control. To build something so big and complex, you needed thousands of workers, careful planning, and huge amounts of resources. A leader who could manage that was clearly strong and respected. A third idea is that pyramids were used to watch the sky and mark important times of the year. Because so many pyramids are perfectly aligned with the sun, moon, or stars, it's possible they worked like calendars. In farming societies, knowing when the seasons changed was extremely important, and pyramids may have helped track those changes. All of these theories may be true to some extent. The truth is, different cultures probably built pyramids for different reasons, and often for more than one purpose. Some people may have chosen the pyramid shape simply because it's strong and easy to build tall, without advanced tools or materials. The oldest known pyramids are in Egypt, where the Great Pyramid of Giza was built around 4,500 years ago. But Egypt isn't the only place where ancient people built pyramids. In South America, the Caral civilization of Peru built pyramids about 4,600 years ago, making them just as ancient as those in Egypt. The more famous pyramids of the Maya and Aztecs are much younger. Most of these were built between 2,500 and 1,000 years ago. In Nubia, modern-day Sudan, pyramids were built starting around 2,700 years ago. These were clearly influenced by Egyptian designs but developed their own unique styles. In Asia, pyramid-like structures appeared later. The huge stone pyramid of Borobudur in Indonesia was built about 1,200 years ago. In China, the tomb of the first emperor, which may still hold the famous terracotta army, was built around 2,200 years ago. These different pyramids, built at different times and places, show how widespread and meaningful the pyramid shape has been throughout human history. Interestingly, many of these ancient pyramid building cultures shared similar techniques, even though they were separated by oceans and centuries. In Egypt, Central America, and South America, builders created step pyramids with carefully cut stone blocks, inner chambers, and exact alignments with the stars. This has led some researchers to wonder whether there was a transfer of knowledge across the world, or whether different civilizations figured out similar methods on their own. A fascinating example is the use of corbelled arches, a technique used to make stable rooms inside thick stone walls. Both the ancient Egyptians and the Mayans used this method, which shows how advanced their understanding of architecture was. Some pyramids even include advanced math ideas, like the golden ratio, and reflect deep astronomical knowledge. It's remarkable that structures built thousands of miles apart, sometimes with centuries between them, can show such similar complexity and cosmic alignment. While no one can say for certain if these cultures ever contacted one another directly, the similarities between their pyramids suggest either shared knowledge or a natural human drive to build in certain ways. Archaeologists are still exploring these mysteries, uncovering more evidence that might change how we understand the ancient world and the connections between its people.